Well, Erik, again, I'd like to thank you very much for providing us this beautiful setting for this interview. And before we get into your technical career and business career at Tandberg, I'd like to learn a little bit more about your background, how you got to be an engineer, where you're born, where your grandparents were born, whatever you'd like to share with us.
Okay. I was born in 1945 in Oslo. My father was an engineer, electrical engineer, and I think I inherited a lot of his interest in technology. They say that when he was trying to do something, my nose was closer to what he was doing than the rest, all his tools. So my grandfather was a teacher from the west coast of Norway, and was extremely interested in reading everything. So he could read days and nights just to learn more. And he never understood why his pupils didn't understood that it was necessary to work hard and read, because that was what he had been doing all the time. So I learned a lot from him also, because he always impressed on me that if you had time to spend, do something, read or learn something, don't sit there. So that's been a little bit of my background, at least.
Where in Western Norway?
He was at an area called Møre and Romsdal, and the place he was coming from, Solhjell. Sol means sun, and Hjell is a ravine or a creek or whatever you call it. So sun shining down into this deep ravine. And it was a nice little place, but very poor as far as I know. They didn't have a lot of money. So he came to Oslo and became a teacher in Oslo, and then married, and then my father was born, and then later he married and I was born.
Mm-hmm. How about your grandmother?
My grandmother, her father was an architect, and they lived in Oslo, had been living in Oslo for quite some time. So she became a teacher, and was also very focused on teaching and learning people new things. So she really enjoyed. She was even teaching some girls up to until she was about 85 or almost 90 years old. So I have it from her too, I think.
And your wife?
My wife is from a town called Porsgrunn, very close to Larvik, and she's a nurse and has been working as a nurse all her life, but now she's retired.
Mm-hmm. And her parents?
And her father was head of company making porcelain here in Porsgrunn, and he was also very doing a lot of good work during the war. So he was involved in war and was also imprisoned during the war.
Oh, really? In the resistance?
In the resistance, yes. And her mother was also from the same area, basically.
And that area was?
Porsgrunn, which is close to the town here, about 15 minutes away from here.
Okay. So it was your father's interest in electronics that got you into electrical engineering and into university?
I guess so. And I started at the university, technical university in Trondheim, back in 1965, and educated in 1969. And then I had to go to the military for 15 months. And actually in the military, I did a lot of pilot testing to measure the pulse when you start and landing, especially to see how high it goes. So I was measuring, using tape recorders, I was measuring this on the pilots in the force, in the Norwegian forces.
You mean G forces?
No, not G forces, but the pulse, the heartbeat.
Oh, heart rate.
Yeah, heart rate. And the point was that they had some accidents where they were wondering whether people could have been having a too high heart rate, and therefore something happened. So that's what I was doing.
I understand your hobbies are...
Yeah, it's either working with model trains. I'm building a system of a model train at home, not finished, but hopefully I will one day. And then I like taking pictures, so I take typically 5,000–6,000 pictures every year. So and store it, of course.
Yes, it's a good thing we're digital photography and not film anymore.
Now it's digital only.
But you were a Nordic skier at one time?
Yeah, I have been doing. I like Nordic skiing, and we still do. Not so much as we did before, but we have a cabin up in the mountain where we go to every winter several times, and also during Easter. And we may have ski tours up to about 30 kilometers at the most, I guess, on a day.
It's very good. I was impressed when you met me at the road junction here, your ability to run down the road as fast as I could drive the car. Clearly you're in pretty good shape.
I like running.
And you ski jumped, but
my ski jump I did at one time, and then one day I was just landing with the skis directly down, right down vertically, and that was not a good move, to put it that way. So that terminated my ski jumping operations.
What was your engineering degree like at the university? What subjects?
Oh,
what did you like?
First of all, I was a little bit different from the other people because I actually educated in radio. By the time I finished, almost all the radio factories in Norway had gone, so that was not a good move. But I actually took my thesis in medical electronics, measuring heartbeat and other things on patients. So I was one of the first ones in Norway doing things like that. So I got a very good grade on that one. And I think there were only 2 or 3 of us doing that at that time. Now it's much more popular, of course.
Was your curriculum tube-based or transistor-based?
It was partly tube and partly transistor. It was just a transition period.
Yeah.
So I know both, but I'm more familiar with the transistors today, I think.
My class in the university was the first one to teach transistors before tubes. Taught both.
Okay, yeah.
But we as
You switched?
Freshmen first course in amplifying devices was transistors, and then they taught us tubes as a transistor with a high input impedance.
Yeah, all right, okay.
But everybody else before me had been tubes first.
Yeah, yeah.
So we're both of the transition era.
Yeah, I think, I believe, I cannot remember whether we did tube first or transistor first, but it was about the same time. But and also we were one of the first classes talking about digital circuits, like the 74 series and things like that. So I was very familiar with that one.
I switch back for a second to ask about your wife's grandfather who was in the resistance.
Yeah.
Is that story known in the family, and is it?
It's known in the family. He didn't talk much about it, and actually, I think for a long time they had an agreement that he shouldn't talk about it at all. But he did talk about it towards the end of his life, and he's also mentioned in a book written about the group he belonged to. So there is we know a little bit about him. And he was able to escape, for example, from a car together with another guy and so he came away and got over to Sweden and things like that.
I suggest if there are things you remember that are not written down, you should write it down for your grandchildren.
That's probably a good idea.
Before it gets lost.
Yes, that's probably a good idea. I agree.
Okay, so now you're a university graduate.
Yep.
And you're...
Finished military.
Finished your military.
Yep.
Were you an officer, enlisted man?
No. I was just a hard-working soldier. Yeah. And
in the air defense, though.
In the air defense.
Is that in the army?
Well, it's a separate group, but it's obviously you have air defense, you have marine, and then you have the regular soldiers. Okay. So and that's why I was 15 months, because that was the length in the air defense.
Okay. So you're now looking for a job.
Yeah.
How'd that go?
It went very well, actually. Because during my university time, I met a boss guy called Gustav Ring, who had a company in Oslo and making dictaphones and different kind of tape recorders. And we met each other, and we became a little bit of friends, I would say. So he said that, well, when you finish, Erik, come and see me, because I think we could use you at Gustav Ring. So that's why I started there. So I never really applied for a job. I got it almost immediately by asking him.
His name was the same as the name of the company?
Yes, Gustav Ring, yeah.
Company name, person name.
Yeah.
Okay.
And so I was there for a little bit more than 1 year, and had a good time, learned quite a lot, trying to make different kind of digital electronics. One of the things we were working on was an exchange system for different kind of money. Because at that time you didn't have euro all over Europe, you know. So it was an interest in the banks to have a system that you could automatically exchange different money from different countries. So we were building a system like that and installed it at the airport, at the bank there, and a couple of other places. But then one of my friends from the university had been working for Tandberg. And he called me and said, we need a guy with digital experience to come and work for us on tape drives. And I didn't know anything about tape drives, but I said, okay, I'll do it. So then I started with Tandberg in '72.
You describe yourself as a digital engineer this time, so you're doing digital circuit design, not analog circuit design.
I did a little bit of analog, but I would say I'm not a good analog designer. I'm definitely a digital designer. Okay. And to some extent also I have done a lot of programming in the past. Actually, part of one of the first years at Tandberg, we designed what you would today call a microcomputer, but discrete digital components, and build up a small software system which we used to program it. So that was my first step into programming, actually. Mm-hmm. Except I did it at university, of course.
Okay. So now you're a new digital engineer at Tandberg.
Yeah.
Tell us about Tandberg early on.
Yeah, Tandberg, Mr. Tandberg himself started with radio, building radios back in the 30s, 33, 34. And then in 1948, he hired a guy, Mr. Nødtvedt, who with a plan to start developing audio tape recorders. And they developed, over the next 4 years, they developed the first Tandberg tape recorder, introduced in 1952, just before the Olympics here Winter Olympics here in Norway. And it became a big success. And then they built on that and had a series of very nice audio recorders built during the 50s and the 60s and the 70s for that matter, with very high quality and very, very reliable units. Actually, there was one unit, Tandberg number 5, I think, Tandberg Audio number 5, which was bought by John F. Kennedy and recorded all his phone calls and many of his discussions in the White House while he was there, including also during the Cuban crisis. So that was a very famous moment, of course, for Tandberg to sell a tape drive, audio tape drive to the White House. And then towards the end of the 60s, people started to talk about digital tape recording. And Tandberg realized that he had to do something. So he hired 2 guys from Norwegians, which have been working in the US. I have it here, Mr. Gunnar Reichborn Kjennerud, who had been working for Potter Industries in the US, and Mr. Peter Breivik, who I believe worked for HP in the US. And both of them were very good engineers. And they started on 2 different projects. One was a reel-to-reel half-inch tape drive called TDM 1000. And the other one was a small tape drive based on using the 3M cartridge, which was just launched at that time. And they did a very good job, yeah. Talking first about the TDM 1000 tape drive, that was a challenge because they tried to do a lot of new things in the drive. First of all, it was with vacuum column and with optical sensing of the position of the tape, and a head which was brought back in order to load the tape and then brought into contact with the tape, which had to have a very, very high precision. And the challenge of building this mechanical system was much, much bigger than we anticipated. And also the problem with keeping the air flow stable so that you had a good position, correct position of the tape was a challenge. Actually, the power supply just to keep this whole thing running was about 2,000 watts. And it was a lot of air. And I remember we had one of the companies, or one of the areas where we were working was with the universities, and we were dealing with CERN in Switzerland, France. And I remember a guy coming up from Switzerland who had a reel tape with him with his data, and we put it on to demonstrate on our tape drive, and then something went wrong, so the tape was just sucked down and came up as confetti, you know, on the top, spaghetti on the top there. And the guy cried and said, "My data!" and it was lost. So that was our first shot on trying to keep data stored for a long time. It was just a few seconds, so it was not very good.
Do you recall the mechanical engineers on the project?
No, I don't, unfortunately. Actually, Mr. Kjenner himself did a lot of mechanical design himself. He was partly a mechanical designer, so he did a lot of design himself. But it was also another guy there, but I unfortunately don't remember his name.
This was an early use of electronic sensing in the...
Yes, this was, as far as I know, fairly early in sensing, and the problem we had was the sensors. They were not very stable, and especially when temperature changed, the position changed quite dramatically, and that was what happened when the tape died when I tried it. So that was a problem. We Technically, we only worked with 9 tracks on this, NRC1 and later phase encoded PE. So, and we got up to about 45 megabytes, which was quite a lot of data at that time.
How fast was the mechanism? 125 inches per second?
Well, no, I think it was 75.
75.
75, if I remember correctly, yeah.
Did you do a faster version, or was...
No, we never did. I think, again, the problem was this positioning. We tried to increase the speed, and then suddenly the one tape went down and sucked into the area, and then we had the same problem again. So it was a little bit of a nightmare, frankly. And it took some time to really learn how to do this.
Your key customers?
Well, we had one really important customer, and that was Litton Industries in the United States. And they were doing oil, drilling for oil in different places in the US and other places. And one of the things they came back and said, we have a problem, because at that time the tape drives were what I call start and stop. So they started, then you could record a block of data, and then they stopped again, and then you could start again, and they had another block of data, and so on. And the problem is that the start and stop time was fairly long, relatively speaking. And typically when Litton used this, they were drilling a lot of holes in the ground, put dynamite in one hole and sensors in all the other holes, and then they wanted to record the waves when the dynamite exploded. The problem was that typically the explosion happened when the tape was stopped or on the way to be stopped. So they said that, I remember one of the Litton guys said that, well, it's only 1 out of 5 explosions which we really get a good recording of, and that's not very good. So we had a hard time working with them, because they basically told us that if you don't do anything, we cannot use tape anymore. We have to find another way of recording this. And then I came up with the idea of what is now called streaming tape drive, which was probably around 1974, if I remember correctly. And basically I can talk about that later. The whole idea of the streaming tape drive was to avoid doing the start-stop. Instead, I let the tape run all the time and write the blocks, and continuously stopping the writing, and then just recording some error correction and some preamble and postamble, and then a new block, so that we avoid almost the whole timeout between the data blocks. It's just a very short timeout when you are writing the preamble and postamble, and later error correction and CRC and things like that. So that was, we invented this, or I invented this back in '74. I went to Mr. Tandberg himself, told him about this, and I said, I think it's a very good idea, and we should make this tape drive, and we should sell it to Litton and all the other guys also. And he said, yeah, that's fine, but we don't take a patent on it, because this is so universal that I want everyone in the world who wants to build tape drives to also be able to use this idea. So unfortunately, we didn't do it, and a couple of years later, almost all the tape drives were streaming tape drives. I didn't invent the word streaming. That was IBM who invented the word streaming, as far as I know. But the technical development was done at Tandberg.
What did you call it?
I think we called it continuous drive, if I remember correctly.
And you actually made and sold this product?
Oh yes, we made and sold it. We sold it first of all to Litton, and then later to Norsk Data, which was a computer company, fairly big computer company in Norway, and also to Kinsle in Germany, and a few other places, smaller amount. We sold a few to different American companies also, in addition to Lytton.
And this was a model of the TDM 1000?
Yes, this was actually the real TDM 1000. We didn't change the naming. We just introduced the streaming technology and forgot about the other things afterwards. So we went, in principle, we kept the name. We could still call it TDM 1000.
So, but it had the capability of operating as a stop-start.
In the beginning, the first design we did had both capabilities. But later, we only went with the streaming technology, because that was the only thing people were interested in, because it was so much more efficient. But we couldn't, I mean, we used the same, of course, all the electronics itself, the head and everything else was exactly the same. The mechanism was the same and everything. So in principle, it was the same technology, except that we had made this system of blocks with the small gaps in between, where you had the preamble and postamble and error corrections. So we just added that to the original drive.
So presumably you got a much higher data rate, effective data rate than
Effective,
the start device.
effective data rate was about 3 times higher, between 3 and 4, I think, actually, than the original one.
Without changing anything.
Without basically changing anything. And Lytton was very happy, because now they had a hit rate was almost 100%. So
I mean, that's an enormous advantage, cost reduction to them.
Yes, but the problem was also that it was still very expensive to build this drive. So and to be honest, some of the competitors had designs which were much simpler to make and still very good. So we had a hard time making money out of selling this drive. So therefore, it was not the money maker for us, unfortunately.
Well, at least for a while, when you exclusively had streaming, it must have been very popular. But when the other folks in the industry adopted it,
it adapted very quickly. That was what I mean, within 3-4 years, almost everyone had turned to streaming tape drives. Mm-hmm. So it came, and for good reasons, because people needed to have data streaming instead of having start-stops, for many reasons. So,
would it be more accurate to say that, aside from the mainframe industry, everybody went streaming? Because my recollection is
mainframe did not do it.
Contained start-stop forever.
Yeah. Mainframe did not use it for a long time, but except for mainframe, I would say almost everyone else started using it. And also, I mean, the problem with the start-stop drives was that you had a fairly high head wear, because you're starting and stopping, and this is hitting the head very hard. On the streaming tape drive, once you have started, you get a very, very thin airflow between the head and the tape, so you actually don't wear the head so much. So head life was actually better.
Yeah, I understand that to be a religious issue in tape, as to whether or not the tape is flying or not.
Yeah.
In the disk drive industry, we fly.
In disk drive we fly, and in tape we never talked about flying when we had the start-stop operation. But when we did the streaming, we realized that yes, the tape is flying, and the head contour is very critical to have a stable head-to-tape contact, but still with a little bit of air in between.
Now, you were making your own heads at Tandberg at this time?
At that time we did, yes. This came from the audio industry, where we were making all the heads ourselves. So we had learned to make heads. So we made the heads ourselves for quite a few years, actually. And the problem of doing that, of course, is that when you talk about heads with many tracks, it's a lot of very, very nice tiny windings, which with the wages we have in Norway, it's pretty expensive to have someone doing it. So over time we had to find other sources for the head. In addition to the half-inch tape, Peter Breivik was the designer of a cartridge tape drive based on the 3M cartridge, 300 DC300 cartridge, which was launched just, I think, around 1972, if I remember correctly. And that was the idea with the cartridge was that you could have a very simple mechanism by having only one motor driving both reels within the cartridge, and it was a belt-driven cartridge. And he designed a very nice, very robust drive with a capacity of 2.5 megabytes roughly, fairly slow data rate, but extremely stable, and it was actually a fairly big success. We produced it for more than 15 years. So from that point of view, it was absolutely a success, and we made money on it. And actually, the American Skylab station had one of those inside to record data, not because of capacity, but because of it was so stable and reliable. So.
Any particular reasons why it was so stable and reliable?
Well, this goes back to, I think, the history of Tandberg, where Mr. Tandberg himself was very focused on quality and very focused on using or designing for long reliability, long life of all components. We had motors which were never driven to the maximum. They had a lot of margins. The same with electronics. We never pushed the let's say the power maximum to the maximum power, whatever. So we tried to have good margins everywhere. And the other thing was that we also tried to have very solid mechanism with very solid design, so that it could take a smash or a hit without any problems at all. So that worked fine. And we tried to keep it also later when we design new drives.
But as I understand tape technology, one of the bigger causes of unreliability is either headwear or tape wear. Mm-hmm. So was there anything special about the product in that area?
Well, if you talk about headwear in general, of course we also had the same problems like all the other guys. Over time, we tried to learn how to minimize it. We couldn't take it away, but we minimized it by making the tape contour so that we tried to have a stable airflow, as I talked about before, and also have to have some outriggers that could take most of the hit from the tape when you started and stop, so that the actual active area of the tape was not hit so hard. And that worked fairly well. Of course, the tape itself, the head here itself, is a read while write, so typically it was a read write read, so you can operate in both directions. And then we had two outriggers, one on each side, which actually took most of the hit from the tape when it was starting and stopping.
So that will reduce head wear, but still leave you with the tape wear problem, because the hits are the hits.
The tape wear was there. You couldn't take that away. And we have seen good tape and we have seen bad tape. So unfortunately.
Yeah.
So.
Now it used the DC300 cartridge from
Yes.
3M.
Yeah.
How did you get into Tandberg?
Well, I believe that Peter Breivik had seen this cartridge when he was in the US and coming to Tandberg. So he was the one who actually knew about it. And he also had contact people at 3M, which he probably had worked with in the US. So I remember that we had some problems with the mechanism in the beginning. It was not perfect, to be honest with you. So he actually communicated with 3M in order to fix or improve something. I cannot remember what it was now, but I know that he was in contact with 3M.
But Tandberg was not a pioneer with the DC-300.
No, there were other people. I know that HP had at least using that one, and also a smaller one, the DC-100. And there were other people also working with the cartridge. So 3M at one time did a very good job of promoting this cartridge technology.
DC-100 or 300 or both?
Most of, I would say 300 more than 100. 300 was what they probably looked upon as a more professional product. The 100 was more the low-end product, in my opinion. So we at Tandberg, we mainly focused on the big cartridge, what we call the big cartridge, which was 1/4 inch and later 8mm wide tape inside. But it was, in general, a very robust cartridge, and it gave us a very stable platform for building the drive around.
So you also provided, I think in the tape world you use the term formatter,
Yeah.
which I think in the disk drive world we call it a controller.
The controller, yes.
Same. So you were doing your...
We were doing on the half-inch tape. We were making a very large formatter, a fairly big system, because we had to operate with 9 tracks in parallel. And it required a lot of digital electronics at that time. On the DC 300 cartridge drive, we were using a much smaller formatter. But both of them, of course, was designed to connect with a tape drive. Oh, sorry, with a PC. Not a PC, but a computer, to be more precise.
A computer, yeah. We're talking
talking
early 70s.
Early 70s, so there's no PCs
so
yet.
You designed then for different mini computer buses?
Yes, different kind of buses, that was one of the problems. There were not many standards. So what we were trying to do was to see, for example, on the 9-track tape drive, we were looking at what are the rest of the world doing with respect to formatting and interfacing, and then we copied a couple of these formatter interfaces more or less directly.
Do you remember which ones were I expect Unibus, from my experience, would have been an important one.
Yeah, I think we did one Unibus version, but there was also one other version which I cannot remember just now, but unfortunately. But it was one version which was fairly popular in the lower end of the market, which we were doing. But to be honest with you, I think everybody had their own strange implementation, so that if you were a computer guy, you had to implement for a specific formatter. So very little standardization. And that was one of the things I learned actually from that experience, was that standardization is very important. If you don't do standardization, you put so much more burden on the customer side, and that's not good. Unless you dominate the market, of course.
Yes. I think that actually, in most computer peripherals, is the experience going into the 70s. Not a lot of standardization. I mean, there was the IBM channel. There was some DEC digital equipment interfaces, but the rest was almost a custom design to attach to a host bus of a mini computer or
exactly,
or any of the mainframes. I mean, if you wanted to attach to a Honeywell computer, you had to design a Honeywell formatter.
Yeah, and you had to do that. For example, when I talked about Norsk Data, they had their own system, so we had to modify our system to match what they had, basically. And that was a problem then, of course, because then you had to have so many different types, which is not very efficient when you talk about manufacturing.
That microprogrammed machine you mentioned earlier, was that used as a formatter?
Yes, that was one of the things we did. I made this microprocessor. It's not micro, it was a fairly big board. But it was made so that we could, instead of using just discrete digital logic, we could actually do a little bit of smart processing of the signal. So basically what it was that when we received the signal, we put it into a memory stack, basically, and then we could look at the different data from the 9 tracks and say, okay, these belongs together, and this belongs together, this belongs together. So we had a sort of a little bit of a buffer, you can say, in the formatter. Not very much, not very fancy, but it worked.
It seems that the tape folks lagged the disk folks in microprogramming or microcontrolling of the formatter controller. I mean,
That's true.
IBM, I think, introduced microprogramming for disk drive controllers in '64 with the 2841, and that was a wide word discrete device microcomputer, which was 12 inches wide by 12 inches deep. Nothing like we think of microcomputer today, but it was called a microcomputer because it was controlled by microprogramming.
Yeah.
But the tape folks seem to have lagged, even IBM and in the non-IBM world.
No, it was very little talk about even doing it for in the 70s. In the 80s, of course, it changed completely. But in the 70s, it was very little talk about it. I think I would say towards the end, the second part of the 70s, you started to see some people focusing on this also. But in general, it was a lot of discrete logic, hardwired logic, even towards the end of the 70s. Mm-hmm. And actually, we also, since we had so many problems with the TDM1000 drive, technically and commercially, we also looked at building a new drive, and we were looking at partnering with another company. So one of the companies at that time in this tape drive business was Cypher, and in the US. So we approached Cypher and suggested that we should make a partnership to standardize. That was one of the reasons, that we could standardize the formatter and the tape drive itself to get bigger markets. Cypher management didn't want to do that, so they were not interested. But 2 of their engineers were very interested, so we actually started up Tandberg Data Inc. in San Diego towards the end of the 70s, where the goal was that they should design a new and much simpler tape drive, and we should design a new formatter in Oslo at the same time. And that worked very well. So towards, I think, 78, 79, we were able to launch this new tape drive with a new formatter. And that worked quite well. And it was significantly cheaper to produce than the old one.
Do you remember the folks at Cypher who decided no?
Dale Spencer was, no, he didn't say no, sorry. He was an engineering manager who joined us.
Okay.
I cannot remember the guys who said no at Cypher anymore, because they were pretty blunt, so it was not long discussion, to be honest with you. But I'll come back to Cypher a little bit later, because we were able to hit them a little bit later. But
so, So the Spencer, I think you said?
Dale Spencer.
Dale Spencer?
Yeah.
And another Cypher?
It was one guy, another guy, but I can't remember his name. But I had a lot to do with Dale.
And so they formed...
They formed Tandberg Data Inc. in the US.
As a startup?
A startup.
Funded by
Tandberg in Norway.
In Norway?
Yeah.
Completely funded, 100%?
Yes, as far as I know. But the problem was that this happened towards the end of the 70s, and Tandberg Radio, unfortunately, because of low sales of TVs, went bankrupt in December 78. So basically, by the time we had the drive and the company and everything ready in the US, the mother company in Norway went bankrupt. So that was not a good situation.
Mm-hmm. And the formatter was being done in the mother country.
Yeah. I did the formatter.
You did the formatter.
Yeah. So this was also, it was not a very modern design. It was a fairly straightforward design, but it was a little bit of programming, microprogramming built into it. Mm-hmm. But not very much if you compare to what you're doing today. Fairly simple.
Sure.
And basically just more or less hardware-related design, frankly. Mm-hmm.
So the parent is bankrupt.
Yeah.
But still in existence under bankruptcy laws?
No, not in Norway. It's different from the US. So basically, in principle, the day you're bankrupt, everything shuts down. And now one guy, typically a lawyer, takes over the control, and he may decide to try to continue if there is some money there. And that's what happened with Tandberg. I remember we actually were working overtime the day we had the bankruptcy. I was interviewed by the Norwegian Broadcasting Corporation, and then I said, "Excuse me, but I have to go back and work." And I remember the guys thought I was just crazy, but we did actually go back and work, even if we were bankrupt. And the point was that we had some business we tried to protect while we were in the middle between the bankruptcy and the new company startup.
This time you were a group manager?
Yeah, I was a group manager at that time. And I was more or less heading the digital portion of the development of the tape drives. And we were also, at the same time, Tandberg were also doing different kind of, let's call it personal computers. And one of the things which we were working on was a floppy disk controller. So I was also involved in a floppy disk controller design. I was working with Alan Sugart, among other, because we were one of the first to use double-sided floppy disk drives from him. Not a very good design, by the way. But
yes, there's a lot of history behind the double-sided floppy.
Yeah.
Do you know Juggy Tandon?
Yeah, I met him. Yeah, but I don't really worked with him. No.
Oh. Yeah, the Sugart double-sided floppy was a very bad mechanical design.
I know.
And they ultimately replaced it by the Tandon magnetics design. And they took a license and got a cross license because Tandon patented that design.
Okay.
But it's
one of the problems with the original design was that both heads were floating, and they were not stable.
That's true. Yeah, we could go offline.
Yeah,
I could share with you hours of stories. I spent part of my career at Shugart Associates just after that fiasco.
Okay.
And so I apologize for Al Shugart and Don Mercero and some of those folks for that era of floppy designs. But you work on a PC before IBM, before contemporaneous with Apple?
Yeah. We're not with Apple. Actually, we had a discussion with a guy from Apple. I don't know who, because I was not involved in that. But then that never turned out to anything. So we were developing our own software system and operating system, and we actually, one of the customers which came on board just before the bankruptcy was Siemens, which was a fairly big company also in computer operations at that time.
Yeah, I mean, you say here you were working on the Tandberg's first PC from 74 to 76.
Yeah, in parallel with the tape development.
Sure, but that's, I mean...
We were early.
You were very early, right. I
mean, we were very, very early.
We can, talk about who was first.
Yeah.
Right.
Yeah.
But
No, we were quite early.
But then that stopped when the bankruptcy happened? Or?
No, it didn't. When the bankruptcy happened, because Siemens had signed up for this, call it PC, they were interested in supporting this. So a new company, Tandberg Data, was started just a couple of months afterwards, and with Siemens as majority shareholder. So Siemens was very heavily involved during the first 4 or 5 years of Tandberg Data.
Mm-hmm. And this is Proton?
Proton, exactly. Because it was Proton they actually used Proton as a startup name there.
For the record, Proton is the name of the successor company that took the tape and PC technology from the bankrupt Tandberg radio.
Yeah.
And then Proton became Tandberg Data?
Yeah. Proton became Tandberg Data.
Okay.
So that's how they kept the system alive for a couple of months. Mm-hmm. Because Proton, you see, was after the war, Siemens here in Norway were forced to change name to Proton.
Ah.
So the Proton name was already available. So they used the Proton name in order to start up this.
I could understand why the Siemens name might not have been too popular in Norway after World War II.
Yeah. So anyway...
But this is 1978.
79, yeah.
79, that's 30...
Yeah. But still, they had the name.
Yeah.
So they used the name. So I was actually hired by Proton for a couple of months before we had Tandberg Data started.
And they just changed the name, or?
They more or less, they came in and they formally established Tandberg Data. And then Tandberg Data took over the whole thing. Mm. So that was, at that time, it was PCs and tape drives. And then we had basically stopped the 9-track old TDM 1000, but we still were working with the guys in San Diego. So we were selling their drives in Europe, and they were selling with our formatter, and they were selling their drives with our formatter in the US. Mm-hmm. But it stopped. It slowly stopped during, I would say, probably 83, 84. I think more or less the sales stopped, because then our focus had turned to Quarter-Inch Cartridge on the tape side.
Okay, but this was a DC300 cartridge tape drive.
Not the one we made in the US.
Oh,
that was a half-inch, reel to reel. It was the difference between the TDM 1000 and the one we made in the US was that the one made in the US was based on mechanical arms controlling the tape.
Oh, instead of vacuum column.
Instead of vacuum column.
Ah, okay. I did not understand that.
Okay, sorry about that.
No, my confusion.
Yeah. So it was still a half-inch tape drive,
Gotcha.
With a regular formatter and everything.
Sure. And with tension arms, lower cost.
Lower cost.
May not be as reliable or as fast, but...
No, it was less fast. I can't remember the speed, but it was like 45-inch or something like that. But still, it was okay.
Aside from the mainframe market, very suitable product.
Yeah, the mainframe market was of no interest to us, frankly, at that time. We didn't have the resources to support it, and we didn't have the products either, obviously.
So you have the DC300, the TDM 3000?
Yeah.
And you have this half-inch...
Yeah, which was called, I think it was called TD 1050.
And I assume the Tandberg Data Corp in the United States was then owned by the Tandberg Data...
No, well, what happened there was that when Tandberg, original Tandberg, went bankrupt, the guys in the US were able to take over, or they were allowed to take over, I should say, the company. So they basically owned the company in the US. I cannot remember that we had any investment directly, but we had a partnership agreement.
So they had the brand.
But they had the
brand name.
They had frankly the brand name for a couple of some years, but then they changed it because I don't think they felt that it was the right name for them to use, because they wanted to do other things. So they changed the name after some years. I cannot remember now what they called them, but they changed the name after some years. And that's why we could use the Tandberg name again later in the US.
Okay.
We're
backing up to talk about a little bit about the Siemens PC and the problems with the floppy disk and the controller Erik was designing.
Yeah, the problem was that we had decided to go for the double-sided floppy disk drive from Alan Shogart because we wanted as much capacity as possible. And I designed the floppy controller for that drive. And I thought that it was working okay, but then when we started to test out more units from Shogart, we found that everyone was different, so that it was not a reliable system. And this was very close to the launching of the PC to Siemens. So Siemens got a little bit of panic, I think, and they sent 5 guys up from the headquarters in Munich. And I remember going into the meeting room, and they were sitting there, of course, dark dresses, you know, very, very serious. And I explained everything, why this was a problem and what has happened. And they didn't say very much. But then at the end, they said, well, how long time do you need to fix it? I said, well, give me 1 month and I'll do it. I'll work day and night and I'll fix it. And they said, do you know how to do it? I said, yes. I didn't, but I had to say yes. And then they didn't say anything more, but 2 days afterwards we got a letter from Siemens saying, okay, we will wait 1 month with the launching. So I worked literally together with one of my colleagues day and night, and we had to do a complete different design, because where we had to introduce much more flexible data handling by using this system of buffering, so that we could look at data which was actually flexing all the time. And we got it in 1 month, but I was extremely tired by the end of that month, and we launched it. And then I remember some years later, I asked one of the Siemens guys I met in Munich, I said, you didn't say very much, and I didn't hear very much afterwards either. So why did you come 5 guys up to Norway? And he smiled and said, well, you know, we wanted to understand what was going on, but we were also very surprised that some engineers really would admit that he had done something wrong, and you did. So anyway, it worked.
I'm impressed you can come up with an electrical solution to what is fundamentally a bad mechanical design.
Yes, but as long as you understand what is bad, you can typically find ways around it, you know. But my problem originally was that I didn't understand why it happened, because I didn't realize how bad it was flexing.
And the flexing caused amplitude modulation.
Amplitude modulation.
Which requires a very different type of detection.
Very different kind of detection. You had to. It was actually probably my first shot at sort of I wouldn't say partial response, but a predictive detection system.
Yeah, no, did you try to convince Shogart to buy the design from you?
No.
They could have used it.
They probably could.
No, I mean, in the end, they abandoned that head design,
yeah,
that mechanism design, and went with a license on the tandem patent. I think the original Shogart design was called tri-compliant because there were 3 degrees of compliance.
Yeah.
And the tandem design was called bi-compliant, and ultimately they badged all of their products as bi-compliant, double-sided bi-compliant, which was a mechanical solution to the problem.
Yeah.
Also, I think that must have been sometime in 1976 or earlier, because I think Shogart was forced out of Shogart Associates in 76. Or maybe 77.
I think it may be 77. I would think. I believe. I'm not quite sure, frankly, about that.
Well, if the name Don Massero.
Yeah, I know him.
Because Massero replaced Shogart as the head.
Yeah, I met him once.
Yeah, but Don is and was a really good engineer. compared to Al, who was a really good manager
Yeah, he was a good manager, that's right. And a very nice person.
and a very nice guy.
Yeah.
Okay, did the Siemens PC make it to the market
Yes,
ultimately?
it did. And
It
it,
did.
actually, Siemens, they didn't sell tons of it, but they did sell quite a few around in their area, mainly in Europe, I believe.
Do you remember the model name or number?
No, I don't. I was not very much involved in that. Because, you see, Tandberg was when Tandberg Data was started, the main focus was actually on the PC and the data terminals, much more than on tape.
Sure.
Because the management, and I guess rightly so, felt that tape hadn't really proven to be a good selling for Tandberg, and while with Siemens in the background, you had a very strong partner on the PC side or the computer side and the terminal side. And the terminals, data terminals, were fairly modern, and for example, they had a keyboard which was not linked or not fixed to the terminal. That was, I think, the first one which was introduced there. So and they had a data terminal which was also had a low radiation, which was people were worried about at that time. So they were selling the terminals to quite a lot of customers all around the world.
And this was their own operating system?
Yeah, but the PC, that sort of died. They switched because then Microsoft came on board, of course, after some time. And so slowly we gave up our own operating system.
It wasn't CPM either.
No, it was not CPM.
It was a Siemens operating system.
It was a Siemens operating system, yeah. But and actually it was originally a Tandberg system, which was introduced, and then it was merged somehow with Siemens. I was not involved in that, so I don't know very much about it. But they were selling quite a lot of terminals. As of the terminals for the first part of the 80s, terminals were really the dominant selling product
for Tandberg.
For Tandberg, and the PCs gradually went away, and we started to try to build up tape drive sales again, and that was a fight. It took time, and because one of the things we realized was that we cannot do it with half-inch tape. We had to go to something which is cheaper and smaller, physically smaller, because everybody was asking for smaller form factor. So we have to switch to the cartridge. That was the clue. But we obviously have to get more capacity in the cartridge, or on the cartridge, than what you had previously. So that's how we sort of started looking at Quick. And I was one of the 4 founding members of Quick. At that time I had met a couple of competitors, like Archive. You had a guy there called Bill Buchan, who is a very nice guy. And we had met at some exhibitions. We developed a 4-track cartridge-based drive with a fairly simple interface, and started to present that to the market in 1980-81. Archive did the same thing. They were based in Southern California, a little bit south of LA. And you had also a couple of other guys who were coming into the same business. So there were basically 4 of us, each with a different format, but all with using the 3M cartridge and 4 tracks, and more or less the same recording technology, and it's typically the same density.
This is Tandem?
Yeah.
Archive? Cypher?
Cypher was part of it, yes, and Tandberg. Yeah.
No, you said Tandberg twice.
Oh, sorry. It was Cypher, Archive, Tandberg, and I wonder if it was Wangtec at that time. Wangtec.
Wangtec?
Yeah.
Could be.
Could be. They may have come later, but I don't remember whether. But it was actually 4 of us, and then somehow, and I can't remember how, Ray Freeman came into picture. And I remember...
This would be early 80s.
81.
Well, Ray...
He was together with Porter heading...
I think that's about the time Ray started the annual tape report.
That's right, he started that.
He started that because Porter started it, I think, in 76.
Yeah, on the discs.
On the discs.
On discs, yeah.
And he and Ray sort of worked together, and I think Ray actually asked Jim Porter, is it okay if you've got this, can I do tape?
Yeah.
And then Jim being the type of person he was, probably said yes, and Ray started that tape.
I think it probably started around 81.
Well, and if he probably started with the mainframe tapes, the 3480s and the reel-to-reels, and then seeing you guys coming up, he
approached us, and then we had a meeting in the US where we said, okay, let's try to standardize the tape format and the interface to the drive so that people can make simple connections, and even if they buy whether they buy from Tandberg or Archive or whoever, Cipher, they can still use the same technology on their side, and the tapes are interchangeable.
Do you remember the principals from the 4 companies who were involved? You from
I was from Tandberg, and Bill Buchan from Archive. Cipher, I cannot remember, unfortunately, no, and not Wangtec either. It was really Archive and Tandberg who were driving this.
Okay, it's not uncommon.
Together with Ray. And Ray did a very good job of keeping us aligned, because we had a tendency to jump out and start talking about nice features and small technical things, and said, hey guys, remember, we have to make sure that you are all compatible, both on the drive side and on the tape side. And do that first, and then you can talk about whatever you want afterwards. So that's how the first standard, the QuickO2, came around.
Now that's an interface standard.
That's an interface standard.
Was it derived from any other interface standard?
No, I think it was built on something which was used in the industry. But it was a little bit different from anything. But it was at least a standard which was fairly simple to implement for typical computers, low-end computers at that time. So, and it was a parallel interface, of course, which was the only thing we thought about at that time. So
data in parallel?
Data in parallel, yes. We had that for quite some time. Actually, the first SCSI interfaces, they were also parallel, 50 line connectors, I think.
50-pin connectors, yes.
Oh, a nightmare with all the lines going up and down, and you had all kind of noise problems and things like that. So.
But it wasn't you. Did you consider SASE and reject
no,
it?
that came. No, it came. We did that later, a little bit later.
But it's contemporaneous. I mean, SASE was promulgated in '79.
Yeah.
I mean, Larry.
Yeah, but it was when we looked at it, and I remember we discussed it at Quick, but we felt it was too complicated. So we tried to remember the goal was to have something low cost.
Yeah.
And not mainframe, not at all. And so we really wanted to have low cost, and therefore we needed something which we felt was easier to implement also on the interface side.
But you were single track, a single reading head.
Yes.
4 tracks, serpentine.
Yes, but we wrote only one at a time.
Only one at a time.
Yeah.
Read only one at a time.
Yeah.
So
only write also one at a time.
Yeah. So bit serial is much cheaper than any parallel.
Oh yeah.
So I'm surprised QuickO2 had a parallel interface.
Yeah, but you see, I don't think we even thought about it, because we were so used to everything being byte-wise moved over, so we just had to get it as a byte and then get it into to the tape as a stream.
Okay, I mean, At that time, I was responsible for SASE at Shugart.
Oh yeah.
The guy who invented it had left.
Yeah.
Larry Boucher.
Yeah.
He'd formed Adaptec,
Oh yeah.
but Shugart was still promulgating SASE at the ANSI committee.
Yeah.
And that was a big step for a disk drive company to go from bit serial, to parallel.
To parallel, yes.
And it was much more expensive.
Yeah, I can understand
so
that.
So it's sort of interesting to see tape, though,
Yeah.
going parallel right from the beginning.
But again, as I said, remember the market we were trying to get was in the low end of the tape drive market, and they had bytes coming out, and we didn't want them to have to convert that into a serial stream. So, but anyway.
But so the objective of SASE was the same, low cost parallel interface.
Yeah.
But it was a bit complex.
It was complex compared to what we were doing.
Well, I'll have to look more carefully at Quick 02 because
it's a very simple interface.
Oh yeah.
So, but I mean, Quick very rapidly realized that having their own interface there, when the disk guys had a SASE, was not a good thing. So everybody moved over to SASE after some time.
Did you bridge? Bridge controller from a Quick 02 to a SASE? Probably that's the way you started.
No.
Embedded the SASE, right?
We embedded the SASE right into the drive.
Who's the architect of Quick 02? Who really?
I think I'm one of them.
You're
afraid.
one of them.
Yeah, I think I was one of them. Afraid.
Okay.
I think Bill Buchan and I did most of the sketches on the design and the defining the interface, and of course the actual design afterwards was different from each company.
Sure, but defining the spec.
Yeah, it's a fairly simple spec. If you look at today, you would say it's very, very, very simple compared to what you do today.
Actually, at Shugart, they had two interfaces. They had one essentially equivalent to Quick 02, which they called SADIs, Shugart Associates Device Interface, which was even simpler than, it was disk drive oriented. And the idea was by putting a SASE on a SADI, you can make it easier for the controller, for the system companies to interface. And that turned out to be true. SASE became SCSI.
Yeah. And
SCSI is one of the, to this day.
It's still. Not, but now, of course, it's serial.
It's serial, and it's under every protocol you can name. You can get SASE over Ethernet, you can get SASE over anything.
Yep.
But, or SCSI over.
Yep.
Anyhow, so this is now, we're in the early 80s?
We are moving into the early 80s. And one of the problems, of course, which we had was that we had very limited resources, given that we had just gone bankrupt. And the main focus of Tandberg was on the displays, on the terminals, on the PCs, and not on tape drives. So we really had only, I would say, 3-4 engineers in the development team in the beginning. And so we had to say, okay, what can we do? And one thing we had learned was how to use the 3M cartridge. And we had agreed in Quick to use the 3M cartridge. So, and 3M came out with a longer tape also. So we said, okay, its possibilities to increase capacity, which was one of the key points here, to at least 20, which was the first goal, 20 megabytes on the tape, which was fantastic compared to what people had at that time.
Yeah, that today is
5
images.
Yeah, it's nothing. It's nothing. Yeah. So that was really the design, and we had one good mechanical engineer, Guttorm Rudi, who was very, very good at designing mechanisms. So the whole thing was that we focused on 8-inch floppy as the form factor.
The full height 8-inch.
The full height 8 floppy, because that became more or less a standard from a computer point of view in the industry. So it said it has to be streaming tape drive in order to keep speed as high as possible, and we use the cartridge, the 3M cartridge, and we try to put more data as possible. And as I said, Archive was the biggest competitor, and at the same time, I think both we and Archive realized that if we don't do something together here, on the interface side and on the cartridge side, we will have a hard time convincing the market to switch to these products. So that's what really was behind the whole quick thinking. We have to work together, and it will create competition, but it will make the whole market much bigger and more opportunities for all of us. And those that are good in utilizing the opportunity will win. So we just have to be better than the other guys. So that was a driving force behind it. And as I said, Ray Freeman was very, very good in supporting the whole work. I was traveling. We had all our meetings in San Diego. I don't know why, because I mean Ray lived in Santa Barbara, but we had all the meetings at Rancho Bernardo in San Diego. So I was traveling in 1981-82. I was traveling to the U.S. basically every month for more than a year. 12 trips in 11 months, I think it was, something like that. So
then the frequent flyer programs were pretty good too. So you probably got some.
I got some. Yeah,
got some good mileage.
I had some. I was flying SAS mostly, and you know that you have been flying too much when you get into a plane, and the guy said, "Oh, hey Erik, hey, there you are again." So, but anyway, we got it.
Ray was the chair of the Quick Committee, wasn't he?
Yes, yes. The formal organization was, I think, was established in, I think, by the end of '82, beginning of '83. It was really formalized, and I mean, we had at the maximum, I think we had as much as almost 100 members. Not all of them drive vendors. A lot of them either working on software for quick tapes, or interfaces for quick tapes, or just customers like IBM, for example.
I think 3M licensed the cartridge designs, or the other manufacturers of.
They licensed into Sony and to TDK, at least. Also licensed it to the guy in the US, and he made it called Gigatape, I think it was called. So there were at one, I think it was like almost like 5 different manufacturers of.
So they would join the
yes
Quick Committee too.
Yeah. So they were all part of the Quick Committee. Sony was there, TDK was there, Gigatape was there.
So you're at this time, I think, technical manager, R&D manager, the senior engineering manager for tape.
I was basically heading the tape.
And you could see the market opportunity would be better with standardization. The guy, your colleague from Archive, was also a technical person?
Yeah, Bill Buchan was also a technical guy.
How did you guys convince the businessmen that this was a better idea? That seems that would be hard.
You know, my boss was Ralph Høybakk, although he was focused on tape, no, not on tape, on terminals. He told me at once that, Erik, if you feel this is the way to go, do it. But you won't get more than funding for more than 3 and 4 engineers. So you better do it in a simple way, and you have to make it a success. Now, Bill Buchan, I don't know how he actually did it, but I have a feeling he had more or less the same thing, although Archive was only focused on tape, and only on this tape. But they also were a startup, so they had to...
You gave them credibility.
Yeah, and also, I think the point was that we were both very open with respect to talking about technical stuff, maybe too open. So when we had problems, when we could see that there would be problems, we could at least, we were discussing it privately a little bit. And of course, you probably shouldn't do that. But in general, you trust each other, and it worked out quite well. And having this close contact also helped us afterwards quite a lot.
Mm-hmm.
So I mean, I've been visiting Archive several times, and they have showed me the production, and we have discussed technical stuff and everything. Even if we are competitors, I think that's a good way of doing it.
I agree at the technical level, but sometimes the business management,
they don't understand.
They don't understand.
No, that's.
But you were lucky that
we were lucky that we had Ralph Høybakk on our side at least, who did understand it,
yeah.
And but I have to admit it was a hard time getting funding. That's it was a lot of hard work, long days, and it took time to develop what we wanted to do.
It's also an impressively small group that you
yep.
had to do the work you did.
Yep. We had one mechanical guy. We had, besides me, we had two electrical guys, one on the analog side and one on the digital side, and that was about it in the beginning.
Yeah, that's
so it's not a big group.
Yeah, no, I mean, actually, an extraordinarily small group.
Yeah.
I think the first disk drive Ramac.
Yeah.
The group was about 19, but that included 4 machinists because back then you had a machine shop. Mm-hmm. So it was, but that's quite a bit more than your 3 or 4.
Yeah. Yeah.
Although I will say that when I joined Memorex to do its first disk drive, there were only 4 engineers.
Okay. Yeah.
I was the 5th.
Yep. There you have more or less the same thing.
Yeah. It's sort of. But today, I don't think you do a disk drive with less than, or tape drive with less than 75 or 100 people.
Yeah. But I mean, looking back, basically Quick lasted for about, you can say from 1982 until about the end, towards the end of 1999, 2000, 2002, 3 or so. And in that period, more than 15 million drives were sold. And I don't know how many cartridges, but quite a lot. So it's not
7 or 10 at times.
Probably something like that. So
yeah, actually, in the disc market, the numbers are 7 to 10.
Yeah, and I think
tape maybe more because tape stays around longer.
Yeah, yeah. Tape much longer.
So
longer. I would probably say, I think I heard someone saying that you can at least assume 20 tapes per drive.
Per drive.
At least.
At least.
At least. So, so we launched the first quarter-inch tape, which was not quick, in '81 with 20 megabytes of capacity and serpentine recording with 4 tracks. But that was not standardized, and we tried to sell it, and people in principle said, yeah, that's fine, but how do I connect it to my computer? It's a special interface. Oh, shit. They don't like it. They didn't want to do that. So that was also part of the driving force behind the Quick thing. We had experience. Archive had exactly the same experience. That it was so difficult to convince people to interface to a single non-standard unit because they want standardization. That became very, very, very clear.
Yeah, again, in the disk business, CDC came out with a new disk pack called SMD. Mm-hmm. Put it in the market, didn't sell anything for 2 years because it took 2 years to design the formatter. Mm-hmm. And then, because it hit a niche, it would turn out to be a big niche. Mm. Once the formatters were available, the market exploded.
Exactly.
It's the same thing. You have to have the particular value that you can drive the customers. But when you have a standard interface, then it's a whole different business. So,
but I think also one of the problems we had with the first drive was that as I said, it was based on 8-inch floppy, Now,
Sure.
but at that time, 5 1/4 inch was becoming very popular form factor, half height, 5 1/4 inch.
Yeah, you were beyond the full height 5 1/4. You're to the half heights.
Yes. So we realized very rapidly that going with the 8-inch form factor, no way.
So this was not your first DC 300.
No, we had the first, the old one, the
3000.
old one. Yeah, the
So
old one.
This was a new one
There's a
in an
new-
8-inch full height
8-inch form factor.
form factor.
Form factor with a streaming tape drive and things like that. But it was 8-inch form factor.
And at that time, the 8-inch market was dying.
It was dying very rapidly. It was 5 1/4 inch half height,
Yep.
which was the only thing. So that was also part of the standardization in Quick, that we also standardized in principle the form factor, saying that, well, we should all have 5 1/4 inch half height, so that with the same interface, the same cartridge, compatible cartridge, so that people really feel that this is standard.
You had a spec, but the cartridge didn't fit.
Well, the cartridge, the problem is that...
Can I just, do you know what the English term, the American term blivet is?
Mm-hmm, yeah.
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 You're approaching a blivet.
Yeah, and that, I don't know if you can show that to... Yeah. The problem was that the cartridge was originally designed to be inserted from the front, where you had the driving wheel, and which is connected to the belt driving the two reels, and it's no way you can put in the cartridge which is so wide into an opening which is so wide.
A blivet.
It's exactly, and that's ended up in a very interesting situation, because we discussed it internally. We realized we have to do it with a 5 1/4 inch half height. It means you have to insert the cartridge sideways.
The wrong way.
The wrong way. And then we worked very hard on finding a mechanism which can actually do that, and not being too complicated. So we filed for a patent on our mechanism, based on a sidewise insertion. And the same Archive did the same thing, and they did it 2 weeks ahead of us. We discovered that afterwards. And Wanktech filed for a patent about 3-4 weeks after us. So we were all, of course we had all talked privately between us, so we were all working on the same thing. The 3 of us filed a patent on this.
Okay.
And the Archive patent, that was the thing. Archive actually patented the idea of inserting the cartridge sideways.
In the wrong way.
Yeah. We didn't apply for a patent on inserting the cartridge sideways, but actually for the mechanism. Yeah. But Archive was smarter. They actually applied for the insertion. And therefore they came to us and said, well, you guys have a problem, because we have a patent here. And so we know that you are violating the patent, and so is Wanktech.
So let me back up for a second. Other people did full height 8-inch.
Yeah.
DC 300.
Yeah.
Were they Quick compatible?
Some of them, I think, for a short time were Quick compatible, but they didn't sell anything, so they basically disappeared from the marketplace.
Yeah. Okay. Yours was not.
No.
Quick.
Ours
Quick 02 or the.
No, it was
either the cartridge.
It was close, but it was not the same, because the format on the tape and the interface was more or less a compromise between Archive and Tandberg. So we took a portion of what they had done and a portion of what we had done and put it together and said, okay, this is a standard.
This is Quick 02 for the interface, and one of the Quick numbers for the 20 megabyte cartridge?
Exactly.
Okay. And now going to the patent issues over inserting a cartridge in an unusual manner.
Yeah.
Did they approach you before the patent issued or after the patent issued?
After the patent had issued.
So this would be several years after?
Yeah, it was not too far, not far along. Actually, it was just a couple of years.
Couple of years.
Yeah, it was fairly rapidly.
But by that time, you'd filed your patent and you'd shipped product based on
We
your
had,
patent.
yeah, we were shipping products. Wangtec were shipping products, and Archive were shipping products. So we all had done that, and then suddenly, Archive came and said, "Hey guys, you have a problem."
Yeah. Now, there's a term in patent art called interference.
Mm-hmm.
And did the patent office raise during the prosecution either any of your patents as interfering with anybody else?
No, I know what you mean. No, no, I don't think it was discovered.
Until they had issued.
No, because we filed the patent in the U.S. first, and so of course Archive and Wangtec did the same thing. So these investigations at the patent office were going on at the same time, more or less, and that's why they were not disclosed.
Well, it's not
No, because
common.
No, but you remember, this was at the time you had a different procedure in the U.S. for patents before. Now you have the more standard European, where you actually present the patent ID in I think 1.5 years after you have actually applied for it.
Oh.
But you didn't do that in, I think, if I remember correctly.
No, but the patent office was supposed to
have access
to the different examiners were supposed to know of other patents in process and could raise an interference between patents even before they issue, and then work with the various patent appliers to resolve or disallow a patent because
that
it just didn't happen.
It didn't happen. Whatever happened, it didn't.
Because the patent office could have come up with an interference and then caused the claims to be resolved.
Yeah, no, I think,
happen.
as far as I know, we all three of us
got your patents.
Got our patent,
and then
we had this situation, and then
your mechanism was not the same as
no. The mechanism was different, but the point was inserting the cartridge sideways.
Now we could argue,
it's obvious.
It's obvious, yes.
Yeah,
that level claim.
Yeah, and that was what we tried. We discussed it with our patent guy in the U.S. And he said, well, you may or may not get through with it, but it's going to be tough. Why don't you try to settle something together with
Good
Archive?
advice.
Yeah. And and then I talked with Bill Buchan again, and we had some discussions, and Bill said, well, if you are willing to support us in our negotiations or fighting with Wangtec, we will make a deal. So he said, we will license 1 or 2 of your patents, and you can license our patent. So I said, fine with us, of course, no problem.
Good deal.
And then I had to stay in the court in the U.S., and the judge asked me whether it was obvious to insert it this way, and I had to say no.
You said no.
Yeah. You see, we had another way of doing it. And that's what we could use it
diagonally.
Yeah. So theoretically, you could have done that.
That's an infinite number. Well, an infinite number of angles.
Yeah. Yeah. And so I said that, and that's why it's not obvious, and that's exactly what the patent lawyer from Archive wanted to hear.
Here, of course.
Yeah. So,
and I'm sure so you testified. Archive sued Wangtec.
Yeah.
And you testified.
I testified for.
You were called by Wangtec or Archive?
By Archive.
As
a witness, I guess. I don't know. As a they call it technical
expert.
Yeah. And I remember the judge asked me whether it was obvious. I said no. And I said, did you look at other alternatives? I said yes, we did, and which was true. I had even drawings with me showing other. And then he said thank you. So that it took 2 minutes. Frankly, it was not a big deal.
Yeah.
But anyway, Wangtec lost.
Yeah.
And that basically killed them. They, I think if I remember correctly, they had to pay like $12 million had to make a deal with Archive, a license fee or whatever. So it ended up that they more or less died away after some time.
Some people are of the opinion it also killed Archive.
That's true. Yes, they lost a lot of focus during that period.
Yes, there's. I interviewed somebody in Boulder.
Oh.
Also in the non-mainframe tape business.
Yeah.
And I think his opinion was that it was a Pyrrhic victory at best for Archive. That
I think one of the things which I could feel was at least that they were starting to focus much more on making money short term than focusing on how can we widen the quick world by coming out with standards that are more suitable for the future. So it was tougher to work with them on new development of standards, or especially on tape cartridge standards. So I felt that they had, I wouldn't say they had lost interest, but they had maybe less resources to do that, or they were wanting to make more money out of whatever they had running in production. So yeah, I think it could be right.
I'll send you a link to that
Please.
interview if you want to read it.
Yeah, I like to do. I like to do that. But anyway.
So tell us about your mechanism.
Yes, our mechanism was beautiful, of course.
Of course.
Okay, let's see here. This TDC 3300 was the first real quick drive from Tandberg. And it started with, it came out in '84, it started with 20 megabytes, but we very rapidly moved from 4 tracks to 9 tracks to get up to 60 terabytes. Sorry, megabytes. I'm so used to terabytes now.
Okay, so this was the 20 megabyte was a quick standard.
It's a quick standard,
and
also the 60 was a quick standard.
Yeah.
And quick 24 was that called.
Mm-hmm.
And that was really the standard which took off from a cartridge point of view, took off in the market. The 4-track, the 20 megabyte, died very rapidly, but the quick 24 with the 60 megabyte was very popular for quite a few years.
Still one element, now serpentine across.
Yes, but 9 tracks. 9 tracks instead of 1. Instead of 4. Sorry, 4. Yes, and the whole idea of the mechanism was that when you inserted the cartridge sidewise, you had a motor just connecting to the driving wheel, or actually the cartridge moved in so that it connected to the driving wheel and the head and the sensors and things like that, and it was a very reliable mechanism. So
the cartridge had to move in and then index over.
Yeah.
So it had to move 2 dimensions.
2 dimensions. Yeah. But it was a very when you inserted the cartridge, you locked the front, and that was a mechanism to move it.
So it was gear system that
it's a very simple system.
Caused the cartridge to move further in and then index into the head area and connect to the.
And I remember
the motors come up. The motor come up.
No, the motor was fixed. The motor was flexible, but it was basically fixed on place. So you moved it in and just a couple of millimeters. And
then that contacts
the contact. Yeah, and the motor was a little bit flexible.
It's a little compliance there, so that tolerances.
And I remember we tested that mechanism for more than 1 million insertions, which was a hell of a testing, frankly, because we had to do it manually. So
really?
Yeah, I mean, we didn't have the mechanism.
You didn't have the people to design an auto tester.
Yeah. So it took I think it took almost a year to test it, but actually.
How many people?
I can't remember.
Running shifts, people pushing in and out.
Production people. We had in and out, in and out, in and out. it was, but I mean, they were running shifts. That's right. But it actually turned out to be a very, very solid mechanism, and we used it for many years, more or less the same mechanism.
Can you compare it to the cipher mechanism?
You mean which cipher?
Well, the one you said there were 3 patents.
Oh yeah. There's the cipher. I don't know. I can't remember the cipher mechanism.
Okay.
I was thinking more about the
Wangtek?
the Wangtek and the archive. I think their mechanism was they had more parts.
I misspoke. I meant archive.
Yeah.
Versus you.
Yeah. Archive. The archive mechanism was. I mean, principle was the same. But they had a different locking, and they, as far as I remember, they had a mechanism which had more parts, and the cartridge was not fixed so reliably. So, and that was a problem because, you know, the base plate of the cartridge is the reference point for the tape, at least used to be, and because therefore you have to have a very good reference between the cartridge locking, the base plate, and the head, and that was one area where I think our design really were shining.
Mm-hmm.
So
versus Wangtek also?
As far as I know, yes, because we heard from several customers who said that they have been trying both archive and Wangtek, and our mechanism was more reliable. Mm-hmm. But I think archive probably was better than Wangtek, as far as I remember. The archive mechanism was not a bad mechanism, but I think we had a better locking and reference point, more stable.
I'm impressed that an electrical engineer can speak so eloquently about these mechanical problems. But
I've been involved in it for so many years, you know,
yeah.
And so anyway, we were always trying to look at how can we increase capacity, and at the same time, for the first time, we also started advertising, and they used me, and I don't know if you can recognize it. It is me.
Slide 24, the good-looking guy in the lower corner is you?
That's me, believe it or not.
Ah.
So. Okay, and one of the things which people were saying, okay, explain why it's so difficult to make a tape drive, this cartridge drive. Why is it so difficult? And I was trying to come up with something which people could understand, and then I started calculating the speed, the distance between the head and the tape, which I knew roughly, and everything. And then I said, well, this is basically like flying a jumbo jet on the west coast of Norway, about 30 meters about the ground, at the speed of light. And I mean, it's just nonsense. But somehow that sentence went around the world. So I have actually seen other people using the same thing many, many years later for different things.
That's interesting. We have the similar analogy in the disk drive industry.
Uh-huh.
But ours is usually something like a jumbo jet, flying a few inches
Yeah, of course.
above the ground, but only at 2,000 miles an hour, not quite as fast.
Oh, yeah.
It depends upon your scaling factor, what you scale by.
Yes.
What you scale.
Yeah.
The disk drive guys use the Bernoulli number.
Oh, yeah.
So,
Okay.
so they're treating it like a wing.
Yeah.
They say, well,
Yeah.
you take the wing
Yeah.
of a head and you scale it up to the wing size of a 747, keeping the same Bernoulli number,
Yeah.
you will get the speed and the height.
Yeah.
But
Yeah.
same
Okay.
thing.
Yeah.
It's just
Interesting.
well, your meters, we're inches,
Yeah.
so
Yeah. But anyway,
it gives you a perspective.
yeah. But anyway, that has that worked out quite well. Anyway, the problem was we had this drive, 3300. We had 60 megabytes of capacity, and people said, give us more. And I remember I was at a conference where Jim Porter and Ray Freeman had in, I think it was in 84 or 85, where this was up in Silicon Valley somewhere, where I was making a presentation of the Quick 24 standard and the Quick thing, and people said, one guy in the 400 people group asked me, well, Erik, tell me, how much data do you think it's possible to put on this cartridge down the road? And I was standing there and I was saying, 500 megabytes. And the whole group, everybody in the whole area started laughing, you know. And one guy came up to me and said, you must be crazy. No one can put 500 megabytes on this cartridge. And even if you could, no one will ever need it. So, well, it took us a couple of years, but not more, and people needed more.
Yep.
So I was wrong and he was wrong. But anyway, the problem with the cartridge, the good thing was that it was fixed guides linked to the base plate with fairly high accuracy, not too bad. And you measured from the base plate and you positioned the head accordingly. As I said, the problem was that the cartridge accuracy was limited to the accuracy of the base plate versus the guides and the tape tolerance. And as you increased the number of tracks and minimized the distance between the tracks and the width of the tracks, you started to have problems, serious problems in being able to read the tracks reliably. So then
because of the dynamic.
The dynamics, the tapes moves up and down. So first of all, you have a difference between the minimum position of the tape and the maximum position of the tape from cartridge to cartridge, and then you have a variation of the tape inside the cartridge as it's running. So I came up with the idea that, okay, let's find the edge of the tape and use that as a reference, because then at least we have removed the problem of different tape width, because there is a tolerance on the tape width, and we have removed the difference between the tolerance between the tape guide and the base plate. So, and the way to do that was to have a system where you can move the head below the edge of the tape, so you know it's below, then start writing. And remember, this is a read while write head, so you have both the read and the write element. Start writing and then looking at the read signal while you are slowly moving up the head. And as the head the right head starts to touch the tape, you start to get a signal from the read element, and then you know, okay, that's the edge of the tape. And you use that as a reference when you move to the different tracks. So by doing that, you take away most of the tolerance of the cartridge itself. And we got a patent on, and that one I remember. Then we could actually do the same thing to archive as archive did to us. We basically said, we will license this to you. And we did it in a nice way. We had some patents which we cross-license patent. We did it also to all the other guys. We said, basically, anyone who wants to, this is necessary for the next Quick generation. So anyone who wants to build next generation will get a license from Tandberg at a reasonable cost.
Now, this was a static adjustment?
This is a static adjustment. It's not the dynamic adjustment.
You're just taking out the static.
But it's taking out
offset.
the static, yeah.
So you still have the wobble.
You still have the wobble, which we've had to solve next time with the Servo system. But it gave us a possibility to increase the number of tracks quite a lot.
And you licensed individual competitors instead of putting the license through the Quick committee.
Yeah, that was a discussion I had with Ray, and I cannot remember exactly why, but Ray said that for some reason he didn't want Quick to have the right to license this patent. He wanted us to do it. I cannot remember why now, but it was something which in the setup of Quick which made it difficult for him. So that's why we did it this time.
But you freely licensed.
Yes.
Was it a one-time fee license?
It was a one-time fee license.
So you didn't try to get a running royalty?
No, we tried, but we decided let's not do it, because that's so much more difficult to reach an agreement when you ask for a running fee. So we said a one-time license is okay.
It all depends upon the amounts, right? You
yes.
ask for too much for a one-time fee.
Yeah.
And one-time fees are hard for startups.
Yeah, but I mean, remember, this was at the time when the startups had already been there for some time, so it was probably easier for them. So I think we licensed this to something like 9 different companies, if I remember correctly, at one time.
And it wasn't a part of the Quick spec, but it was necessary to read.
It was necessary to be able to position it. And I think that was the reason why Ray said that he didn't want it, because if it had to be, he said that there might be other ways of solving this. So I don't want the other guys to force them to apply for or ask for a license.
Well, in the end, you solved it by dynamically positioning.
Yes.
So,
yes. That came
still,
afterwards.
It's interesting to compare the Quick modus operandi from the later LTO, which put all the patents in the LTO in the consortium.
That's right. It's a different way of thinking.
Yeah, it's very different. You think that's partly your heritage from Tandberg?
Could be. Yeah, and we have always tried to be friends with our competitors. Yeah. Even if we are fighting like hell, we still want to be friends. And we had, for example, we had a Quick meeting in Oslo where we invited all the Quick members, and of course they had to pay their own trip. But we invited them out for dinner. We had a big, nice trip up to the Holmenkollen ski jump, I remember. And we really tried to have some nice days here together.
My perception is that may be characteristic of the tape industry far more so than the disk drive industry. I know.
Could be.
I know from the folks I talked to at IBM Tape and at Storage Tech.
Yeah.
That there was much less animosity, people between the companies, between the people of the companies. People could leave IBM, go to Storage Tech, and there wasn't a lot of threat of patents. In San Jose, it was very antagonistic between IBM and people who tried to leave IBM, and there were lawsuits, threatens, and it was not a very pleasant experience. So maybe the tape industry evolved more pleasantly.
Yeah, I think it did, because it was frankly very little problem. And even when IBM sued us at one time, they didn't sue us, but they actually came to us and said that we think you are violating one of our patents. And let me tell you this story. And they, at that time, IBM was our biggest customer. So we said, what does this really mean? But then we started talking with them, and then I understood that it was one patent specifically, one of our patents they were interested in. And then we realized that and we heard it afterwards, they were about to launch a new product where they were using our technology, and they hadn't realized that this was a patent from our side. So instead of going and asking for a license, they actually find some strange thing and said, you are violating this particular patent, which I don't think we did, but we're sitting there and saying, shall we start fighting IBM in court? No. It doesn't make sense at all.
It's very difficult.
So they originally asked for $2 million for their patent and a license to all our patents. We ended up with just doing a cross-license.
Yeah. No exchange of fee.
No change of, but it took us almost a year.
Yeah. Sounds like you had a good negotiator.
Well, I was doing it. But anyway, IBM during the 85 and 86, we got a lot of customers, ICL in England, Nixdorf in Germany, and we started to get more and more OEMs. But it was one goal we had, and that was to get IBM. That was my goal all the time. So in 86, I moved to the States and started traveling to all the IBM locations I could even think about. And it was quite a few I discovered. Over and over again, went into each of them, made a presentation. Typically, I got a business card from only one guy, and that was the procurement guy. And they were all sitting there, nicely dressed and everything at that time, and very polite, asking maybe a few technical questions. And then at the end, they always said the same thing. Very interesting. We don't have any need for this product now. If we have, we know where to go. Thank you very much for coming. Over and over and over again. And I was almost to give up. But then just before Christmas in 86, I got to a meeting in Rochester. And what I didn't know was that they were working very hard on the AS400 system, which was supposed to launch at summer 87. And they had originally signed up with Cypher at that time to have a tape drive backup. But Cypher had problems. I don't know what kind of problems, but I heard it afterwards. They had problems. So when I came in, they first asked me, can you do a half-inch tape drive like this and this and this? And I said, yes, we can do that. But I said, why do you want that? Because we already have a tape drive who's can give you more capacity, faster, and it's much smaller form factor, and it's nice and lower cost probably. And they started listening, and then they said, okay, we'll think about it. Then they came to Oslo in, I think it was January 87. 5 guys there, very nice. We were sitting there, they were going around, and I remember they said, well, where's all your documentation? Yeah, we said, we have this here. Yeah, but we are used to this at IBM. Yeah, but we don't, we are only 150 people. We don't need so much documentation. And I remember one IBM guy said, yeah, maybe that's true. They don't need so much like we do. So they went home again, and then I think it was in February, they said, okay, you got it, but you have to have it ready by summer. And this was a big, big step for us. So because first of all, they had a lot of different things they needed to change. So on the interface and the command set and things like that, they wanted different command set. And they also wanted some improvements in the drive itself.
This should have been a SCSI drive.
This is a SCSI drive. This is a SCSI drive. So there are a lot of SCSI commands which they wanted, which we hadn't implemented, and they needed it. So we had to do that. And then they said, you should be geared up for volume production. And at that time, we were producing maybe at the best 50 per week or so. And they said, well, we may need much more than that. So in July 87, I was standing in Rochester when the AS400 was announced to all the Rochester people, IBM people in Rochester. And I remember the guy announcing it said, well, we want to thank especially Tandberg Data and Erik for being here and having delivered a tape drive in the shortest time we've ever seen. And it was really, really fun to go there. And we went, one of the things which we did was that we went from even at the best around maybe 100 drives per week. We went up so that we, within 2 years, we were producing at the rate of 300,000 drives per year, and without hiring any more people in production. Everything was automatic. We designed, for example, all electronics so that it tested itself. When you turn on the power, it tested itself and said yes, no, or whatever. And we had self-testing of the mechanism as much as possible. So, and robotics, of course, to put in. So, and we had the way we did build up the production was that we had small groups of 6 people everyone was trained to build the whole drive. They had flexible time. They could come in between 6 and 8 in the morning and leave between 3 and 5 in the evening. And one guy, if one guy came in at 6, he could start building whatever was needed on the drive. And then when 2 came in, they could fill in each other. So it was a very flexible system. And I remember we had a meeting with Toshiba management. They came and they said, "Are we allowed to take pictures?" And we said, "Yeah, I think you can." And the guy said, "I have never seen a tape factory like this before. It's so efficient." And it was really fantastic, effective. So we produced around, I think the maximum produced about 350,000 drives a year, which was a pretty good chunk of the whole quick market.
Yeah, 6,000 to 7,000 a week.
Yeah, that was right. It was on average about 5,000 a week, and sometimes even better. So, so that was.
You mean you had those end of quarter pushes that we see so often on the
No, we didn't have that.
You didn't have
no,
that?
we for some reason things went so well, so we were never pushed for that in those years. Later it came, I can tell you, because later we got some more financial people in the Tandberg. that was a big problem. So anyway, with IBM, we also got others. But IBM was by far the biggest one, and IBM also did another thing. They I think it was 87 or 88, they came and said, "Now you have to introduce Six Sigma to quality, to your whole product, whole line and whole company." And at that time, we didn't even know what Six Sigma was. So it was a big surprise for us, I have to say. But we did. We had put two guys on it. One English teacher, frankly, who lived in Norway, very nice guy, and Svein Frodal, who was the head of production. And these two guys built up the whole Six Sigma philosophy so good that 2 years later, IBM came with two guys congratulating us for being the best supplier of the year to Tandberg, and we had a very nice plague and glass stuff like this. I think I may still have it or somewhere. Very nice, and one thing I have to say is that working with IBM was always a pleasure. They were tough, extremely tough and demanding, but ethically, never a problem. They were absolutely fantastic people. So it was a pleasure, but quality focus was high. So I actually have a picture we can show you afterwards where the 6 IBM guys have signed. Oh. This was 87, I think, or something. So we run this one, Tandberg Data, quality in every bit. That was our slogan. So
this was now which model of the still a TDM 3000?
No. TDM was way gone. This was way gone. This was what we call TDC.
I'm sorry.
TDC 3300, and then came 3500 and so on. So
it was a 3300. You won the OEM contract.
Yes.
And then IBM continued with the later models.
Yes, they came with the later model, and we have one slide here.
And it was a quick.
Everything was a quick
standard on the cartridge.
Yeah.
And a SCSI interface.
Yeah. SCSI interface, and so if you can focus on this one. You will see there that the red ones are what we call the SLR. They are the original TDC group, which we changed name to SLR. So the first one was called TDC 3300, and then we changed the name to SLR, single recording, I think it was meaning. And we had the SLR1, which was higher capacity, 125, and then the IBM came in with that one, but then we came with the SLR2, which was 500 gigabytes. Sorry, 0.5 gigabytes. I have to learn this again. And then came on with SLR3, which was 1 gigabyte in 1990.
And each of these then correspond to a quick cartridge spec.
Yes, each correspond to a quick standard. And then we had a very good business with IBM, but I wanted Compaq. And Compaq was a different kind of company. So Compaq, I've been visiting Compaq several times during the last portion of the 80s, and it was a very hard time convincing them to go for tape.
Just an aside, by this time you are moving beyond engineering, although I'm sure you still loved engineering.
Yeah.
And your title is now either Senior Vice President of the entire unit,
Yeah.
or perhaps even CEO.
Yeah, I was. In 1990, I became the CEO of what they call Tandberg Storage at that time. 1991, I think it was, or something like that. But it's basically I was heading the tape company,
Right.
which was a portion of the total Tandberg company. With
So how does it feel to be a businessman and not an engineer, or maybe you never changed?
I never changed. I never changed. I was always thinking technology.
But you have broader responsibilities now, including
Yes.
but it's getting the customer and worrying about the financials.
I spent much. Well, yeah. That of course came up later. But in these years, we had a fairly stable, good income, and so financially, it was not so much of a. It was not so much of a fight, actually. The problem was actually that Tandberg, the other Tandberg, the Tandberg with the PCs and the displays, they started to go down because of competition from the Far East.
Well, and also the PC business. Yes, PC business.
Everything took off.
To the extent they had a classic terminal business,
Yeah.
that died.
That died, exactly.
And you could still compete with PCs replacing terminals.
Yeah.
But your terminal business by 1995 was dead.
Basically dead.
Yeah.
Completely dead.
That happened.
Yeah.
That happened to Memorex Corp too.
Yeah.
They just didn't make the transition from terminal to
Yes.
PC.
Yeah.
And to go to PC, you're not allowed to go. You had to go offshore because you couldn't make it.
We
in
couldn't
the
make
United
it.
States or
Or Europe, for that matter.
or Europe.
No.
Yeah.
But anyway, with Cypher, they came back several times to us and said, "Yeah, we could be interested in tape drive, but we need more capacity. We need much lower price. We cannot pay the price IBM is paying. That's far too much, I'm sure. And so you have to come up with something."
This is with Compact.
This Compaq.
Yeah, I think you said Cipher, but
I'm sorry. I mean Compaq.
Yes.
Yeah. Compaq. So finally, back in 1989, I had a meeting set up a meeting with Compaq where we had our sales guy in the U.S., Dave Griffith, and I had a lunch before going in there, and Dave said to me, "Erik, it's no good in trying to promote what you have. They are not interested at all. So forget it. You have to tell them they want 4 gigabytes. They want it for a low price," and he mentioned some dollars, "and they want for a speed like this, and they want it in 5 months. And if you can do that, then they are interested. If not, let's just forget the whole thing." So I was sitting there, and we took a napkin, and I was thinking, we would take this from what we have today and do this and this and this. Yeah, it's doable. Yeah, I think we can do it. So basically, I went into Cypher. I had no presentations.
You went into Compact.
sorry, Compaq. I
It's
mean
okay.
Compaq. Yeah, I went into Compaq. I had no presentation. I had a presentation, but I didn't use it. And as I was just using, making drawings on the table, and showing them, say, this is what we can do. And the guy looked at me and said, okay, can you have it by 1990, so and so? Because that's when we launched the product. I said, yes. He said then, okay, then you have a deal. Nothing more, no signing or anything at all. And then I went home. At that time we had about 25 engineers. I told them, okay guys, I have now an agreement with Compaq to do this, this and this in 5 months. And the guy said, you must be crazy, Erik. We should have never let you go to Compaq alone. This is crazy. I said, we have to do it. And we did it.
Really?
We worked night and day. I mean, remember, we took most of the technology from what we had, just improved it slightly. And we cut cost everywhere we could cost without going on quality. And we made what is called SLR4, and it became the biggest sales of everything with about, I think we sold almost 1 million units of it over the years, of that one alone. And it came out in 1992, and it actually got into almost all the OEMs, both in the US and in Japan and in Europe. So that was definitely the biggest success we had at all. And from a tape drive point of view.
Now that's remarkable. I don't find it mentioned in your resume.
No, that's probably true.
So when let's nail the time down as best you can right now, and we can correct the record.
It was launched in 92, I believe.
Launched in 92.
Yeah, and
Well, that's what this says. That's what the
oh yeah,
sheet.
That's what
sheet 35 says.
And I think the meeting with Compaq was sometimes in either just before Christmas in 91 or very early in 92. I cannot remember exactly when. It took 5 months.
And that was the SL4.
SL4. SRL. Sorry, SR4.
What did the crew do to you when they got it out in 5 months? Did they throw you in the fjord or something?
No. People were just happy because then we had to produce even more, So everybody was busy. So it was a tough time setting up production. And this IBM picked up this one, and Fujitsu did, and I think Hitachi did, and Siemens did, and several others.
And they were all. This is quick.
This is all quick.
And at 2 gigabyte.
Yeah, 4 gigabyte for that one, and 4 native gigabytes. And the single recording means that it was only one single track doing all this all the time. But of course, at that time we had 3M back in, I think it was 91, had started working on putting servo tracks on the tape, like you have had on a disc for many years, and they felt that that's the way to go also for tape. And they came to us in I think it was in 91, and they came to us and said, we have a system now which we have designed, which is almost finished. So if you want to license this one, you can do that, and it's based on servo track system. So you need to have a head which can follow the tape variation, and you have to design that, but the rest is more or less finished, electronics and things like that. And that was one of my biggest mistakes I've done.
Biggest mistake.
Yeah.
But let me. So 3M came up with the servo system, but they never made a drive.
No,
so
they made drive.
They must have.
But they had
laboratory work.
They had worked on a lot of laboratory designs, and I think they honestly felt that they had done a very good job of putting together packet of information which would be very easy to follow from our side.
Okay. So they didn't approach you exclusively, but they approached
No, they approached everyone at Quick.
as the next generation of Quick.
At the next, yeah, because they wanted to promote Quick,
Yeah.
of course, as much as possible. And this was back in, I think it was 91 or early 92. So it's just when we launched the SLR 4. And then as I said, I did my biggest mistake at Tandberg because I told management that we will do this in 1 year. So you will have a 13 gigabyte, I think we said 10 originally, 10 gigabyte, and ended up with 13. 10 gigabyte drive by in 93 or so. Well, it was 96 before it actually came out. So because first of all, it turned out that the 3M design itself on the servos were not accurate enough. So they had to do their own job better. And secondly, the way they had designed or sketched the design of, for example, the read-write channel and things like that, never worked.
Really?
So we basically had to go back, design a whole new mechanism, still cartridge insertion that way, but now you had to have a servo head with a damper and everything to move up and down and follow. And that by itself took more than 2 years. We have to learn it. It's difficult.
It's difficult.
Yeah, it's difficult.
Well,
and you remember, this is a very heavy head. This is not like a disc head, which is very tiny, nice little head.
yeah, but a stack of disc heads probably
Yeah,
more mass,
yeah,
more
that's
mass
right.
than your
yeah,
head.
that could be. That could be. But the head is, I can't remember exactly how many grams the head was, but it's something like 110, 20 grams or something.
That's a lot.
That's a lot.
The first disk drive I worked on that servoed had a 350 gram
Oh, yeah.
moving, the whole moving mass,
Oh, yeah.
carriage and heads.
Oh yeah, this is only the head, and then you have the moving system in addition. So voice coil system in addition. So anyway, it took us. I remember, for example, just one problem was we needed a damper inside the voice coil system.
Oh, really?
Because we had problem with overshoot and things like that. We needed to follow the tape. And so we needed actually a damper there, and we just finding the right way, fluid to put into that, and get it in without any air bubbles, because that would kill it, you know.
Sure. And no leaks.
And no leaks or anything like that. So it took a long time, much longer than anticipated, and it almost killed the whole top management's belief in tape, because every year they said, okay, how far are you? I said, well, it's pretty close now, and then another year and so on. So that was a big mistake.
Now the servo tracks on the tape,
Yeah.
had to be changed too, or
I think, as far as I remember, there were some changes in the way they were written, but I can't remember exactly what it was. But I know that they were refined from the original proposal, at least.
well, the tape guys like to talk about amplitude-based servos and timing-based servos.
Yeah, and I'm trying to remember. I think these were time-based. I think they started with amplitude-based, but I wonder if I think they went over to time-based after some time.
Which is interesting, as I understand it from my previous interviews with folks in Boulder.
Yeah.
Amplitude-based servos have a dirty name, and everybody's in tape loves time-based servos.
Yeah.
It's just the opposite in the disk drive industry.
Oh, really?
Yeah.
Oh, okay. Anyway, so it was first launched, this product was then 13 gigabytes, launched in 1996. And after a very tough start, I mean, you can see this from the
gap.
From the gap here. It's quite obvious that something happened in the middle there, here. So we didn't do well in that. We produced quite a lot of drives from on the SLR side, but the MLR, the multi-channel, was a big problem for us. But once we got it through, then it actually lifted the sales quite a lot, because suddenly people started to get much more capacity and data rate, and that maybe was even more important than capacity, was the fact that you had more channels in parallel.
So you went now from a single
head,
yeah, single reader element,
single reader, to much more. I think we started with 8 tracks in parallel. And then moved up and down. So we were actually writing in between. So you had the head was covering the whole tape, and the channels were divided down there, like covering the whole area. So you moved, actually stepping up and down, so you were writing in between the other tracks all the time. And that's why you needed to have a very, very high accuracy of the whole movement, and tape control. So anyway, we came out with this in '96, and then we were able to double this again to, as you see here, to the MLR 2, 3, and 4, and with this one was up at 75 gigabytes. So, and that was back in 2002, 2003, and at that time, from 95 and up to 2000, things went very well. Volumes were up. We were the largest IT producer in Norway. Most of the profit were coming from tape. Actually, we were losing sales, losing money on the display unit. So after some years, the whole display unit was sold to another company in Sweden. So tape was really the focus, and this MLR technology, this multi-track technology, gave us the opportunity to increase both transfer rate and capacity very rapidly. And so for some time, I would say 4 or 5 years, we were really meeting the demand of the market. And it was frankly only, in my opinion, only Archive who were competing with us. It was really Archive and Tandberg who were doing this. The other guys were sort of falling away, and few of them were concentrating on the smaller DC cartridge, but a lot of people just gave up because it was a very complicated technology. We also introduced, with some of the last ones here, we introduced partial response maximum likelihood technology for the read channel.
Did you keep the mechanical damper throughout the whole line?
Yeah.
Yeah, that's interesting.
And we actually even used it on LTO.
Really?
Mm-hmm. And it worked very well.
Really?
Yeah. I think we were the only one who used the damper.
I'm surprised at the use of a mechanical damper.
Yeah.
But the disk drives use electronic damping.
I know. But we used mechanical damper, and it actually worked very well.
Actually, at one point in my career, I had a mechanical damper on a disk drive, and really got to hate it.
Yeah, I can believe that. So in 2001, we announced that we had shipped 3 million drives of the quick drives.
Slide 36.
And it's, I would say, in one way, things were going very well. But on the other side, I started already back in 96, 97, I would say, I started to realize that we were coming to sort of a physical end to what we could do with a tape with the 3M cartridge, because there were, for example, the belt itself created problems when you started to increase the speed. You had slippage between the tape and the belt, and as long as you were moving fairly slowly, it was no problem. But as you increased the speed, it started to become a problem because you got air trapped between the belt and the tape. So then you didn't have full control over the tape movement anymore. And also the aerial density, given the limitations within the tape and the guides, the fixed guides, you know, no, they were not, no pressure on the top of the guides, for example. So they were fixed. All these things started to create problems. So already back in '96, I realized that if we want to do anything more, we have to look at another cartridge, and we have to look at half-inch tape again, like coming back from many, many years ago.
Now, about this time, according to your CV, you moved from being the CEO of Tandberg. You were then a senior vice president at the parent level.
Yeah.
But your focus didn't change.
My focus didn't change, but the focus within Tandberg changed, because in '95 we got new owners, at least some new key owners, which were much more financially motivated than business motivated in general. So they were looking at short-term profit more than anything. And that, because of that, I started to see that they were not willing to invest in projects which had a horizon of maybe 2 or 3 years. At the maximum, they said 1 year. And then suddenly I realized that designing a new tape drive, for example, with the team of about 30 engineers I had at that time, and doing that in 1 year, if you should do everything from scratch, no way. So in some way you can say that we were hampered by the short-term thinking of the top management, which I was struggling with, and that became more and more problem. And also the CEO was replaced almost every year, and that's not a good sign.
Not a good sign.
That's a terrible sign. So, and I remember I had presentations for the board where I said, we have to look at half-inch tape. And the guys looked at me and said, yeah, let's do a license. Who can we license? And Quantum, the DEC, the original DLT from DEC Digital Equipment, was basically the only one which we could even think about. So I got the task of setting up an agreement with Digital, or later Quantum, to start using DLT or an SDLT, which they had at that time. And we had good negotiations with Quantum and no problems, no bad feelings, but I didn't like it because it took away resources, both on the management side and on the technical side, to set up our own production of DLT drives. And we had no control, and we also discovered that there were quite a few problems with the drives themselves, so which we learned the hard way when we started producing them. So, but anyway, we made a license agreement and we started delivering DLT drives to some customers, but
DLT or SDLT?
We started with, actually I think we started with DLT, but then we switched rapidly to SDLT. Yeah. So and then in '98 Compaq acquired Digital Equipment, and that was a big problem for us, because just before, half a year before that, we have signed a big deal with Compaq on the SLR, the MLR4, MLR3 drive, and we have built up. They were going to launch this in sometimes late '98, I think, and we had built up production for a long time and ready to move, because that was a requirement by Compaq. Then when they signed up with digital equipment and bought digital equipment, the management of Compact said, don't sign up anything until we have decided what products we will have in the future. So suddenly we were sitting there with a whole production setup and I think about 2,000 drives in stock, all marked with Compact, and everything ready. And sorry, they didn't buy one single drive. So that really started to create problems, and that hit Tandberg financially pretty hard. And then
I'm surprised there wasn't some sort of a
should have been
payment for disruption.
Yeah, it should have been, but Compact was so big that they could basically insist exact on what kind of agreement.
Really?
And we had to say yes, 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 thank you. And I don't think we ever thought that anything like this should happen. We were probably very naive there. We never ever thought that that would happen. Remember, this was at the end of 2000. Everyone was talking about what will happen when you pass 2000, and we had to store data and everything. So storing data was very, very critical. And sales were good and everything. So we thought, yeah, let's do it. And Compact had been a so nice customer for us, in addition to IBM. But anyway, it's created a lot of problem. And what it really meant was that the top management and the board said, tape is not good anymore. We should move away from tape. We should really try to find something else. And they looked around and said, automation is the way to go, tape automation. And there were a lot of discussions around the possibility of doing that. In the meantime, as I told you earlier today, back in 95 or early 96, I had a nice meeting with John Thiel at IBM, we were very good friends. And as I said, at that time I had already realized that we would need some sort of half-inch tape down the road. So I made a sketch on a piece of paper when we were sitting there at dinner, and said, why don't we do something together with a tape cartridge, half-inch tape cartridge? Let's beat DLT and do something. And John was very pleased and very interesting, and I never heard anything. I also actually talked with HP because I had a good friend at HP in Bristol, and I did mention to him also that maybe we should talk about doing something to beat DLT. This was in 96. I never heard anything, and then back in 2000, IBM and Seagate and HP launched the LTO1 consortium and announced the first LTO1. And I asked John afterwards, as I told you, why didn't you invite me in? And he said, well, the lawyers didn't want to have any outside US coming in here. So that's that. So we were sitting there with SDLT, which was old technology. We were sitting there with MLR cartridge quick technology, which was going towards the end of its life.
Sure.
And the board said, let's just lay off all the tape guys.
Wow.
So that was the third period in my job life. I had to find something which could solve this problem.
Let me back up your discussions with other companies about a next generation. Did you get as far as the idea of a single reel cartridge? Was it?
We talked. Yeah, that's what I proposed to John when we met, because to me it was fairly obvious that you need to have control over the tape and the tape speed and the way you move the tape and the guides and everything. So I have a patent on a tape cartridge, which is a sort of trying to take away some of the problems with the DC 300 cartridge. But still a cartridge with two motors. but we decided, no, we won't do that. It has to be a single reel. That makes much more sense.
Implying two motors with the corresponding cost issues and control issues.
Exactly. So it's better to use a single cartridge.
Now you were familiar with the 3480
Oh, yeah.
cartridge by that time, so
Yeah.
you
knew very well.
that was a single reel cartridge. So the
concept was known, and of course you had the DLT, which is also a single reel cartridge, and the SDLT. So yes, I mean technology-wise, we knew that this is something which can work well, but you have to do a better job than what was done with the DLT, because there were too many things there which didn't work out quite well. So, and actually IBM did a very good job of designing the LTO cartridge. So they really had learned quite a lot of lessons.
Well, yeah, it's not uncommon for the team to do a better job the second time around.
No, that's probably true.
I mean, how many times have your experience when it's one of the problems in the disk drive industry back in the 80s and 90s. There were so many startups, a team never did a drive twice.
No.
Right? It was rare that you do one and you quit and do a startup, and the people who inherited it had to fix it, and they went someplace else. Yeah. And again, Squires at Codata, it was a remarkable difference, and it helped make that company grow.
Oh, yes. But anyway, so after 2000, first of all, the market suddenly dropped because people had bought a lot of storage before year 2000, and now they didn't need it anymore, at least the new ones. So the market went down, and people, as I said, at a high level in Tandberg, started to say, let's move to something else. And so during 2001 and 2, we had a lot of internal fights and discussions what to do. And in 2003, we launched the last quick tape, the SLR 150, 75 gigabytes native. Very, very nice drive, very, very solid. But I also knew that was the end of it. And the board had basically said, no more tape drives development at Tandberg. So then I finally asked them, okay, give me 50 million Norwegian kroner, and I'll take the 35 engineers we have and start a new tape company. And I will go for LTO, and we will build an LTO drive in 2 years. And I remember a meeting with one of the board guys, and he said, 2 years, I have heard that IBM spent 4 years to do this. How can you come and do it in 2 years? I said, well, we have a lot of technology from the MLR and SLR drives, which we can use, but we need new mechanics and, of course, some other things. So it ended up, after a very hard fight, I started Tandberg Storage back in 2003. And as a CEO of Tandberg Storage with 35 engineers and 50 million Norwegian kroner. So I knew at that time that 2 years were probably a little bit optimistic, and I also knew that 50 million definitely was optimistic, but that was maximum what I could get. So we started the development, designed a whole new drive with as much as possible of the technology we had from previous one, but of course all the new definitions of LTO was new for us, and we had to learn that. And within about 1.5 years we had the first prototype ready, which was, I would say, 80% okay. But one thing I didn't have realized was how long it would take to get approval from the LTO group, because they had a formal approval set system, which was very good. It was nothing bad with it, but it it worked much more slowly than we had anticipated. We thought we could just call them, and say, hey, we come over next week and we would like to test this. And basically I said, no way. This is a formal test. You have to be sure that you are 100% ready to go to production before you come to us. Because if you fail this one, it will be several months before you have the next shot at testing. Because we can't run this testing every time you want to do it. Which I can understand, frankly. So I'm not negative for that. I understood that. It's a fairly big job of sending over the tapes and showing that it's 100% compatible and things like that.
It's also a nice way of keeping out competition.
Yes, you said it. But anyway, so I lost, instead of launching by summer 2005, we launched it in autumn, around I think September, October 2005. And the interesting thing was that we had shown this design to IBM, which has used our tape drive for a long time, IBM Rochester. And I went to IBM with our first design back in '84, I think it was. And we presented what we had done and everything. And I don't know what happened, but at least we signed up with IBM to ship half-inch tape drives based on the LTO cartridge, half-height drives, to IBM Rochester instead of IBM buying them from themselves. And I was very proud of that, I have to say that. And that, once we started delivering to IBM, the product went very well, and we also afterwards got Dell as a big customer. We also had other customers. So the LTO 2 product, which was the first we launched, actually got up to volume quite rapidly. And again, we had built it like we did on the SLR line. So we more or less did the same thing with respect to production as we had done with the MLR. So we had a very good start, I would say. And the problem we had was that Tandberg Data was the largest shareholder of Tandberg Storage, more than 33%. And because of that, they insisted that we should have an agreement where they should be responsible for the sales toward both end users and OEMs, but we should help them, work together with them on the OEMs. And we shared some of the profit, but they took a good portion of the profit, to put it that way. So this was an agreement which was supposed to last for 2 years, from 2005 until end of 2007. So we said, okay, let's do that, because then we don't need to build up a big sales channel. I was basically the only sales guy in some way. But the problem was, of course, that we were very successful. By the end of 2007, we had, first of all, we had launched several products. We had launched both LTO1 after LTO2, and then LTO3 and LTO4, and in a very short time period. So we had basically picked up the time we lost in the beginning with LTO. So we were almost at the same time as the other guys, not completely, but pretty close. And we had, by the end of 2007, we had roughly about 28% of the market of half-height LTO drives in the world. So from that point of view, numbers were very good. From profit point of view, it was terrible, because Tandberg Data took 70% of the profit. So that's why we told them that from 2008, we have to sell directly to the OEMs. Tandberg didn't want that. Tandberg Data didn't want that, because they had bought Exabyte a couple of years earlier, and that was a big mistake. It was basically, I think they lost $25–30 million when they bought that company. So what happened was that Tandberg were Tandberg Data were saying, no, we have to go on like this. We will not let you sell by yourself, even if we have an agreement to say so.
Really?
And it was there were lawyers, there were discussions for half a year, and then they did a very bad trick on us. I have to say that was a very bad one. They basically, 50%, roughly about 55% of the volume went to OEMs. The rest went to the distribution channel through Tandberg Data's resellers. And now a lot of the profit came from the distribution channel, less from the OEM channel. Without us knowing it at all, Tandberg in June of 2009 signed up with HP that by the 1st of July they should stop taking drives from Tandberg Storage to their distribution channel and only buy HP drives to the distribution channel. So suddenly from July that year, sales went down 50% roughly because we lost all the distribution sales, and profit went down 75% of the little profit we had got. So it was no way that the company could get along like that way. I mean, there was not a chance.
And the distribution folks were happy with the change of supplier?
I don't know, to be honest, because that was Tandberg Data people, you know, and I didn't talk with them too much at that time. And they were all over the world. I don't think they may not even have known it because, you know, I think actually that HP put the Tandberg logo on Tandberg Data logo on the drives, so they probably didn't know that it was another drive. So anyway, what happened was that the shareholders were given an offer to buy, to sell their shares to Tandberg for a very, very low price, and they had no way out, so they basically had to do it. And then Tandberg Data took over. They laid off basically all the engineers, including myself. And then half a year later, Tandberg Data went bankrupt because they couldn't make it. And then, of course, Tandberg Storage was bankrupt too the day after. So that was a sad story, 39 years.
Why do you think? I mean, it seems like did not seem like a reasonable financial business decision to make that switch.
No, it was not. And I think if they had been smart, they had made a proposal for some closer partnership again or something like that, which could have made it much, much better for both of us.
Yeah, I mean CDC had a captive relationship with NPI. I mean, it's sort of, you know, where NPI really didn't make, they just earned a nominal profit on manufacturing and development, but all the sales and marketing went through CDC. And it sounds like
it's very similar.
Well, except that you know, it was in both NPI and CDC's interest that both succeed.
Yeah.
Sounds like Tandberg Data.
I think actually the problem was that the management had sort of mentally said to themselves, we had to get out of tape. So they were so focused on other tape technology, this tape technology, and they were so focused on automation for some years. So they spent all the money and time they had to focus on automation, which never ever worked, frankly.
But you know, it's the alternative to cutting a deal with HP might have been to spin Tandberg Storage out as a complete entity.
And that would have made more sense, in my opinion.
As a observer, it seems to make more sense.
Yeah. No, there
weren't those discussions.
No, not at all. Not to my knowledge, at least.
Well, you should have been involved.
Yeah, I should have been involved. So basically, then in 2009, I was not working for Tandberg anymore. So then I accidentally jumped into data or securing data storage by encryption and hardware encryption. and came over a patent which was from a Chinese professor working in Norway, and started working on that one in this company, and we're trying to do, I can send you a resume of that one too if you want to, and trying to do something there, and but finally we had to realize that no, it's difficult to find funding. It's just too complicated. So then I sort of, in 2013, I basically sort of retired. And then I was asked to come and head the production for a company called Hidden, which is also working on data encryption and storage, securing data. So I've been doing that since then. I'm still doing it. I've been heading the company for some time. Now I've
full-time employment?
Full-time employed. Now I stepped down a little bit in a way that I'm not heading the company, but I'm responsible for all the logistics, production, and participating in the design and things like that. So,
and Eva is happy to get you out of the house?
I'm not sure about that. So that's what I've been doing after now.
Well, I think that's a good place to back up maybe and let's talk briefly about your inventions. You have 20 or so.
Yeah, I'm a little bit more than 20.
We talked about the edge
seeking,
which I think is this one, 444.
I can't remember
67503. It's called Method for the Recognition of an Edge
that's
of a Magnetic Medium.
Yeah, that's the one.
Any other patents that are particularly exciting or interesting?
I have a new patent now, which is just was approved in Norway, and we have filed it in the US and Europe now for involving let's say data encryption control via the mobile phone, but in a secure way. So we'll see how that could be an interesting one. The other ones, a lot of the other ones are variation of the different tape requirements, sure. And most of them are now fairly old technology, frankly. Mm-hmm. And I've been playing around with a lot of different technology. As I told you, we had talked about this cartridge where you had two reels with a built-in motor. Actually, was one patent where we could control everything internally, but a lot of them didn't fly because either they were too complicated or they were probably too difficult to implement and make them cost effective compared with other technologies. You know, one of the things which, if you look at what has happened in the tape industry, is that when I started working on tapes, there were quite a few tape drive manufacturers and disk drive manufacturers. Then everything almost exploded with the number of both disk drive manufacturers and tape manufacturers for some years. And then basically everything is down to almost zero now, just a couple of big players, and that's it. And therefore introducing new storage technology, which has been my background, is extremely difficult because you already have an established market there. So we worked with a company for some time on a sort of a digital storage, silicon storage, but not in the normal way, not in the way it's done today, but in a different way, a different chemical way. We were looking at that for some years, and we had some interesting discussions, but it turned out to be too difficult because it was using light to address the bits inside a silicon system, and the chemistry was too difficult, frankly. So I mean, storage has been my business for 40 years, more than that, 50 years, basically, now.
So what do you predict for the tape storage industry? We're down to one manufacturer.
Yeah, and I think IBM can probably continue for quite some time because there is a need for long-term storage, reliable storage. And I also been involved in a company who was working on using photographic storage of it's a different way from the old one, but it's still very much the same thing with cartridges and everything like that. And they are still delivering products, but these are for people who want to store data for 300 years or more, you know. And I think if IBM can continue developing drives which have reasonable capacity and handling of the cartridge and everything, and do that in a way that people know that yes, this data can be read 50 years from now at least, then they have a market. But the problem is that as the industry is moving so quickly on the computer industry, the interface side changes. And because the interface side changes, you suddenly adapt that, yeah, we have the drive and we have the tape, but we don't have the communication anymore between the drive and the computer, the new computers. So somehow you have to keep these things alive so that you always can read the old tapes on systems which can connect to new computers. And that's a challenge. So,
or you just keep the old drives alive.
Yeah, but that's also a challenge. That's a big challenge, frankly.
Well, it depends upon the volumes, I think.
Yeah, that's true.
I mean, you know,
yeah.
The original Ampex videotape recorders are still out there, and there's a business in refurbishing heads to keep those VTRs running, and you know, people have the archives of tape, and you know, they want to play them back, so they will spend a lot of money for I mean, I talk about $50 disk drives, you talk about $5,000 tape drives. These guys are talking about $50,000 tape players. I mean, there can be a business.
It can be a business. I agree. I agree. And that, as long as that is going on, I think tape will still live. But it will not be the high volume product that we talked about 20 years ago.
Yeah, the argument, though, is tape still has a lot of headroom.
That's right.
Disk is running out of headroom. Semiconductors running out of headroom. Semiconductors, 10 electrons per bit. I mean, you can't go below one.
No, it's difficult.
That's impossible.
It's difficult, that's for sure.
So, so the argument is tape, which has got 2 orders of magnitude of headroom?
Yeah, I would say so.
Something like that?
Something like that. I mean, IBM has talked about 50 terabytes on an LTO cartridge.
Okay.
And I think that's definitely doable.
And I think they've demonstrated laboratory
much higher than
much higher quantities, and you know, approaching. So the capacity may be there with difficult engineering, and of course
the cost will be pretty high.
Yeah, but the data cost per bit may be lower.
The cost per bit is not bad. No, that's right. But I think also the problem is that you have to have a system that can operate the tape effectively, so that because it's, I mean, the problem with the tape is always that the data you want is out there,
of course,
and you are here. So it takes time. So somehow you have to have a system to very quickly get hold of the tape, the data you want, and get it onto something else, so you can access it more quickly. Access time is important.
To some data. I mean, that's why we have a hierarchy.
Yeah, that's right. So, no, I mean, if you look at the number of bits being stored every year in the world, it's going like this.
It's got to go someplace.
Yeah, that's right.
Tapes.
I sure like to start working on tape drives again if I could.
But you have to get the cost of them down below $5,000.
I know.
So you talked about your biggest problem or challenge was the introduction of the Servo.
Yeah, the MLR1.
MLR1.
Yeah, that was from a technical side. That was my biggest mistake. Yes.
Other big mistakes you'd like to warn people about?
No, I would actually say I think the biggest mistake people are doing engineering is being too careful and not daring to really jump forward and say, let's take the risk, let's do it, and let's show people that we can. I have seen too many engineers being too careful and want to think about everything before they really start, and by the time they start, competition have already gone there and they have lost. So I try to forget all the things I've done wrong. As I've done many things wrong, I'm sure, but I try to just look at what I have achieved on the positive side. And I think one of the things which at least people have said to me that I've been fairly good at is motivating people, saying, yes, we can do it, and we will do it. And by doing that, you can get people to lift stones which they normally would never be able to lift.
I think that was your SLR one.
That's
did you keep that piece of paper you sketched?
An SLR4. No,
SLR4?
No, unfortunately, I gave it to Dave Griffith, our guy over there, and I don't think he has it anymore.
Oh, that would be a memorable piece of paper.
Yeah, I should like to. As I said, 1 million drives out of that piece of paper.
Yeah.
So.
Okay.
Okay.
Well, I'd like to thank you very much for the Computer History Museum for sharing your history in tape storage. Mm-hmm. And I wish you good luck in your current continuing activities.
Thank you.
It's been a pleasure spending the last few hours with you in your beautiful fjord-side home.
Thank you. It's been a pleasure also on
my
side.
My side.